もなくオープニング V 入ります。オープニング V 途中でね。
皆さん、こんにちは。ライニャオで CTO.
Hello everyone, I'm Yubin, the CTO of Line Yahoo. Thank you very much for being part of Tech Fest today. It's been almost 3 years since LY Corporation emerged. We've been shaping a new business vision suited for the time of AI, while also building a development culture as LY Corporation. We continued hosting Tech Week to foster the development culture. Tech Week is a week-long festival where engineers from both LY Corporation and Global Group join together to discuss about our technology and future. We place more weight on practical sessions this year. While we deliver selected sessions of TechVerse to our external partners, we also expand venues to experience a real project as a team member of AI-driven development through workshops. Together with Hack Day, we want to make it a week to learn, try, and build. In this keynote, we would like to introduce these 3 themes: LY Corporation AI Service, Agent I, and the technology that enables it, and LY Corporation AX. First, Agent I. AI is evolving at an astounding speed, but the ratio of regular AI usage in daily life is still at 16%. LY Corporation is trying to fill in this gap. LY Corporation already has Line Messenger service with more than 100 million users, and Yahoo search engine, media, commerce, and payment services, covering almost all functions needed in our daily life. We are going to turn these assets into agents. Agent I for individual users and Agent I for business accounts now that has more than 100 million accounts. We are trying to evolve the user's daily AI experience to the next stage. First, about Agent I. Agent I is not simply turning functions into agents. It is to connect multiple agents to provide what is needed before it is searched by reading the intentions, not the keywords, thereby delivering the optimal convenience in all scenes in everyday life. That is the essence of Agent I. For companies, we will leverage LY Corporation's unique strength, mini app, and official accounts. We plan to provide the Line official account AI mode and Agent I the operational and highly analytical functions to all companies that has an official account, enabling them to incorporate AI functions into their own services. All companies connected to Line Yahoo can drive a DX. That's the environment we're trying to establish. Now, how can we make the existing business and services more convenient. Let's show a video. Let's say, for example, we have a line talk. Let's go and visit, have a look at Ginsen. And we have a candidate date to go see the match. In the clip, we have a candidate date from our friend, but then we have a slow response from our friend. Now, agent I will give a reminder so that the group can accommodate a date. And once the date is determined, it's been shared, and it's also registered in the official calendar. This makes our daily life much easier. Business account also have a new function like this. Hello, Oha-san. Thank you very much for all your patronage last month. How can we help you today? I would like to make a reservation for 4 on the 19th or 7 o'clock on the 19th of April. Well, 7 o'clock is already fully booked. We still have some room at 5 p.m. or 5:30 p.m. How would you like that? Let me confirm. 19th of April, Sunday, from 5 p.m. This is a table for 4. I'm sorry, can you change that to 20th? Yes, we can change it on the 20th from 5 p.m. Would you like to have a table for 4? Yes. Thank you. I think this will make your daily life much easier and more convenient. Now I would like to invite Namiki-san, who is in charge of AI platform, to share the current status of AI platform serving as the backbone of our services.
Hello everyone. I'm Namiki from the AI CPU in the CTO domain. You have just seen LINE Yahoo's new service, Agent I. It understands the user's intent and provides convenience. It is truly exciting, isn't it? Today, I will talk about the technical mechanism behind the scenes that make Agent I work. Today, the world is full of convenient AI frameworks and open source tools. However, simply wrapping these tools and placing them into our environment is not enough to build the enterprise-level platform we are aiming for. So today, I'd like to talk about how we are tackling these challenges. This is an overall picture of our AI agent platform. First, build and manage. It's a layer where agents are created and managed. This layer includes components such as Agent Builder, which enables users to launch agents easily even without specialists, and Agent Catalog, which manages what kind of agents are available. Next, Run and Orchestrate. It's a core execution layer. It safely and quickly runs many agents. It also finds the most suitable agent from among many candidates. Then it passes the user's past experience to that agent. The selected agent then performs tasks on your behalf. The platform also connects agents to various tools. By connecting them to Gen AI models and to the data held by each service, the agents can operate intelligently. Finally, the entire platform is supported by a foundation that controls quality and safety, governance, and observability. Today, I will focus on the essential components within this architecture organized around 3 pillars. So these are 3 pillars: democratized agent development, high-precision personalization, and governance. In this order, I will explain the design philosophy behind our platform and the technical challenges we take on. First, democratization of agent development. To rapidly create a large number of agents, democratizing development is essential. What we provide is a UI-based agent builder. On runtime, by simply defining property signs, the APIs to connect to, and the internal tools to use on the AI, users can deploy autonomous agents. Even people who are not AI specialists, such as planners, can launch an agent in a single day. Democratization here does not simply mean creating a UI that anyone can use. What is important is enabling people to quickly turn hypotheses into working forms and learn rapidly from real user reactions to accelerate trial and error. At the same time, the more freedom we provide, the greater the risks around quality and security. Anybody can create, publish, and connect that can impact the quality and security. That is why Agent Builder and Runtime has governance and scalability built in. Being able to build quickly and being able to operate safely. Achieving both is the first challenge we had to solve as an AI agent platform. In fact, within just 2 months of release, more than 100 workflows have already been created. So the component that plays an important role in allowing agents created through Agent Builder to access internal data is MCP Hub. When agents access existing internal data and APIs, managing the connection path can be chaotic. That is why we built MCP Hub, fully adapting the latest Open Standard Model Context Protocol, or MCP. By consolidating them, it's easier to use from Agent Builder, and governance is more thorough. MCP Hub has 3 major functions. The first is runtime, which runs MCP servers themselves in a scalable way. The second is gateway, which connects MCP servers already built in separate environment, and catalog, which visualizes what MCP servers are registered. Therefore, the MCP server providers can publish their servers on MCP Hub through simple procedures. Users don't need to write any complex authentication code. On the Agent Builder's UI, they can simply approve connections to the necessary MCP servers with a few clicks. Currently, more than 150 MCP servers are connected, and the Hub centrally monitors and controls all of them. By using MCP, it can standardize the connection interface. However, what we want to do is not just to provide MCP servers. What's important here is to make it possible for the platform to control the moment it's called. So which tools are being provided? Is it read-only, or does it include updates? Which agent is in what user context can call to what scope? And from agent perspective, maybe it's just calling the tool, but from the system, it includes various functions like authorization, schema validation, rate control, logging, retries, and fallback mechanism. In other words, MCP Hub is not only a catalog of servers, it is also the control plane for tool calling. Developers can use it without worrying about detailed authentication, implementation, or connection management. At the same time, the platform can track who has used which tool through which agent and with what permissions. This abstraction enables both no-code connection and enterprise-level governance. As more connectable agents use this, the next question becomes which agent should the task be assigned to. Instantly finding the agent best suited from a user's single utterance. The central routing is handled by agent router. We cannot afford to select an agent that does not match the user's intent, but if it's slow, the users may leave. Balancing accuracy and speed is therefore extremely important. A router interprets the context behind natural language and dynamically dispatches a request to the optimal agent. For a small group of agents, it may be enough to pass the user input and the list of agents to an LLM and ask which one's good. However, as the number of agents increases, this approach quickly breaks down. The reason is simple. Context length, latency, cost, and evaluation difficulty all increase at once. For that reason, router needs to be designed not as a single LLM call, but as a multi-stage search and decision pipeline. First, it uses metadata registered in agent catalogs such as profiles, capabilities, and policies to quickly narrow down candidate agents. This can use not only keyword search, but also embedding-based semantic search. Furthermore, in production operation, we must continuously evaluate whether the correct agent was selected. Therefore, it can use different models for selecting candidates and deciding on the context. Also, we continuously evaluate if the correct agent was selected. Router is not merely a dispatching logic. It is a core component that combines search, ranking, LLM reasoning, and online evaluation. It directly affects the overall experience quality of Agent I. So far, I have talked about the mechanism for creating, connecting, and selecting agents. Next, let us look at how the selected agent understands the user. This is a second pillar, high precision personalization. In order to realize the idea of another version of me, it is essential for the agent to remember the user. What supports this is a long-term memory. The interaction history between users and agents is summarized and compressed by the memory summarizer, then structured and stored in the memory bank. This is not merely a system for saving logs. It is a mechanism for keeping memory in a form that can be searched later and used in responses. Currently, an average of 7 memory entries are stored per user, and agents use this memory to return more personalized responses. However, the truly difficult part begins after memories are stored. Next, let us look at how those memories should be handled. If we think of long-term memory simply as a mechanism for saving past conversations, we miss the point. Just like human memory, just remembering everything doesn't lead to good experience. Temporary schedule, an old preference, a lifestyle habit that remains unchanged, and sensitive information. Each of these needs to be handled differently. For Agent I to truly become closer to another version of you, it must decide what to remember, what to update, what to forget, and what to protect. Moreover, we cannot put all remembered information into the prompt. We need to retrieve only the necessary memory at the necessary level of granularity at the necessary timing. This involves technical elements such as summarization, search, ranking, access control, and data protection. What matters in long-term memory is not the amount of memory. What matters is the ability to use meaningful memory safely. So what's meaningful to the users should be deployed safely and at the right timing. So that is the technical challenge that supports the high precision personalization. The next challenge is the memory aggregator. LINE Yahoo Corporation has many services, and we hold valuable data sets such as residential area, nearest station, and purchase history. The memory aggregator is a concept for aggregating this profile data and the long-term memory accumulated by each agent in real time at the moment the user speaks. We view this as a context engineering problem. The quality of an LLM response depends not only on model performance, but also heavily on what context is passed to the model at that moment and at what level of granularity. Of course, for example, long-term memory profile information and user history to the model, we cannot pass all of this all at the same time. We determine the context to inject into the prompt by considering factors such as relevance and other things. We need to decide which confidentiality needs to be applied. Therefore, we choose certain attributions and relevance, freshness, reliability, sensitivity, user consent, and the objective of the agent as we determine the context to inject. So here, using what memory is the most important factor, and by creating AI that can remember only what is necessary when it's necessary, we will deliver high precision personalization that only Line Yahoo can provide. So next we will speak on governance.
The first factor is cost control. A lot of our tasks are handled by general-purpose large language models, but if several tens of thousands of agents continue using large models only, the cost and latency would be unsustainable. So what is needed then is model routing. It's extremely relevant, but it's not just simply sorting expensive and cheap models. Depending on the difficulty of the task, the necessity of inference, and the sensitivity of data, a requirement on latency and the cost limits. It's selecting the right model or at execution. Sometimes a small local model isn't good enough for sorting and regular conversion. But on the other hand, for all user IDs, very complex planning, maybe large models will be more suitable. When it's a very sensitive privacy information, it's important that we have a standalone environment on device and locally. Currently, we utilize OpenWay model for local models, but now we have the regional agents. We want high tuning models and have a system to evaluate the platform. From agent runtime perspective, this is routing. But it is from a control layer to optimize cost, quality, and privacy at the same time from the entire platform perspective. The next factor about governance is the control of quality and policy. As tens of thousands of agents emerge, Agent Catalog acts as a hub to protect the order and quality of the platform. This is not a single list of agents. There is a policy in place to strictly control what could be connected to Agent I. Long-term memory would be shared with which agent, and Agent Catalog is the heart of the platform to centrally govern service down health check. The entire agent lifecycle is controlled here. The third factor is the guardrail to ensure the safety. Unlike conventional chatbot, AI agent will make decisions on behalf of the user, call tools, and take actions on external systems. The more convenient service is, the bigger the responsibility platformers shoulder. malicious rewriting of prompts, contamination of personal information, response or actions deviating from users' intent. These risks could not be prevented by individual agent developer. And also to enable personalization, we are accumulating a lot of important data and leveraging them. AI is convenient, but on the other half, we see more black box. Can you leave to the black box an important system and important data? That is the reason why we incorporate 5 guardrails developed in-house. Prompt injection, masking of personal information, detection of harmful contents, and detection of off-topic contents, and information classification. What is important is not a one-time filter at the very end. It is the run control built into multiple sites of agent runtime by designing agent value. So that guardrails is not just a simple filter. It requires to be built into multiple sites of agent runtime. At the time of input, we need prompt injection and detection of harmful information. For tool calling, we need to understand whether there's any personal information or sensitive information contained. And at the returned value of the tool, or we want to make sure all that the personal information are removed. And also at the final response, we need to ensure there's no policy violation or off-topic. So guardrail is a safety device outside of the model, but at the same time is a run control. What we built in-house is to enhance the quality and the safety of the AI agent platform. So as I mentioned, what truly drives Agent I is not the superficial AI experience. At the back end, there are development platform to agilely build agents, memory platform to understand the users more deeply, and governance platform to feel rest assured to leave the task to Agent I. We will create and deliver unconventional convenience in AI experience and wow by putting these together in one platform. Thank you very much. That was mostly it about the platform. Now I would like to turn to Yivin to talk about the AX plan. Thank you. Thank you very much, Namiki-san. As Namiki-san talked about the LINE Yahoo LY Corporation's platform. Now I would like to talk about the AX challenges. For a new challenge in a new and small size environment, we can easily convert AI into our system. But when we have 30 years of legacy, more than 100 languages in our service, AX in a large scale is a totally separate story. I would like to talk about this conventional and universal complexity. How does LY Corporation face this challenge is the next topic I would like to share with you. In order to overcome the difficulties, LY Corporation have taken action strategically and progressively. We have a 5-step approach to AX plan. We have a build and enable phase. And this year, we are moving to the next step, execution phase. We want to accelerate our effort for AX in our entire company. First, I would like to talk about the build and enable phase that we have been working on. In order to make progress, we have created 37 large-scale cross-functional projects and split them into 3 groups. The first one is AI platform, and to prepare the in-house infrastructure for AI. The second one is to prepare an environment for AI ready. And last but not least is to develop the solution in the AI ready environment. So these are the 3 steps. Today, I would like to talk specifically about the environment for AI readiness. System and data and people. We want to ensure that all 3 factors are ready for AI. We have turned the existing system to API and turned them into MCP. All system and data in Line Yahoo will be connected to AI. So we want to make AI a neurological network in our company. And through training, we want our human AI ready to foster AI native human workforce where all people, all human talents can fully utilize AI. Now we are moving toward the execution phase to accelerate our efforts. We have seen many cases boosting productivity by tens of times by leveraging AI. In CS, where AI could be rapidly deployed, we've seen phenomenal productivity gain, like 80% increase or more. But the execution phase I'm talking about is not simply a personal individual level or productivity gain, but to expand that to the organizational wide productivity gain, or otherwise implement not partial implementation of AI, but the entire company-wide implementation. So working from parts to the entire company, individual to organization. Now first about the front line of challenges. Service production. The core of AX for service production is AI-driven development, and we've already seen a new lightweight service has quickly adopted AI-driven development. The significance does not lie here. The legacy service groups supporting tens of millions of users should be the target for the stable deployment. What's most important about the legacy is not the coding, it's the planning and the design phase. So therefore, AY Corporation is structuring legacy specification documents into AI-readable forms by domain or splitting large services to visualize dependency to make earnest progress in AI ready at a plan level.
We are also beginning to see some results from making these legacy systems AI-ready. Over the past year, the number of design documents structured for AI has increased by approximately 46 times. Additionally, the coverage of repositories that are ready for AI has reached about 15%. We're also steadily seeing productivity gains. Over the past year, in existing legacy services, AI-generated code has come to account for around 20% of the total code output. This year, as we move forward in earnest, we aim to raise this figure significantly. So I have spoken about the code output. However, to measure the true results of AX, we need more accurate and multidimensional indicators. That is why, starting this year, Line Yahoo Corporation is using production lead time as a core metric. We plan to measure progress through a multi-dimensional framework that also includes AI utilization rate, QA quality index, and DORA metrics. legacy processes exist not only in the production layer, but also in second layer processes such as security, privacy, legal, data compliance, and Gen AI governance. The lead time in these areas also accounts for a significant portion of the overall production lead time. We are therefore moving forward step by step with AX in these areas as well, starting with making them AI ready. First, a project is underway to visualize and integrate the overall second line process, with the first release scheduled for July. So this time we plan to transform approximately 30% of the overall processes through AX. As an initial result, we have confirmed that this can reduce overall lead time by about 13%. Going forward, we plan to gradually expand AX to the remaining systems. Now let's look briefly at our infrastructure area. In last year's keynote, we introduced Flavor, LINE Yahoo's private cloud platform that integrates and evolves the previous LINE Cloud and Yahoo Japan Cloud. Flavor has now been opened internally, and a phased migration toward FY 2030 is scheduled to move forward. Building on that, this year we are taking another step forward toward a cloud interface that AI agents can use safely. Having AI agents operate infrastructure is not simply a matter of issuing commands in natural language. So the premise changed fundamentally from only humans operate to both humans and agents become users. So the core question in this transition is not whether agents can operate, but it is how far we can safely delegate operations to AI agents. LINE Yahoo is building an environment to thoroughly verify agent permissions step by step as we move toward our next goal, AI native cloud. Finally, let me talk about security. As AI evolves, security risks are also increasing rapidly. In response, LINE Yahoo Corporation is comprehensively strengthening security across 3 axes. First, to use AI safely, we are creating an environment based on trust by design, including guardrails and agent permissions. And to build AI safely, security is involved from the early stages of development, and we are designing together from the beginning. We are also using AI to detect vulnerabilities in advance. And finally, to operate AI safely, we are strengthening security through global-level monitoring. At the same time, we are taking proactive measures by redesigning our infrastructure toward a zero-trust model. On top of that, we are working to create a safer environment through a cross-functional governance framework. I have covered a lot very quickly. So the details of these topics will be presented properly in the sessions that follow. So I hope you will stay with us and enjoy the sessions until the end. I believe many of you are excited about these new challenges while also facing difficulties. We feel the same way. Even so, LINE Yahoo Corporation will not fall behind the speed of change. We will make the most of AI, building on the assets and strengths that only LINE Yahoo Corporation has, and continue delivering the best possible services. By bringing together experiences, let us open up a new future together. Thank you very much for your attention.
Hi. Okay, hello everyone. Hello. Okay. So, welcome to the AX Challenge panel discussion, which is going to address the LY Corporation Group's initiatives with all the key people across the operating departments and how they are taking on reform of building things. We're not going to be talking in abstract terms, but actual success cases and issues being faced on the ground. I'm from the Service Infra Group. I'm not the CTO, the TDO. My name is Yoshioka. It's a pleasure to be here. Okay. And with that, we have 4 panelists that we will be hearing from, whose discussion I will be facilitating. We only have 50 minutes today, so not a lot of time together, so let's get straight into it. Beginning with a quick self-introduction from each of our panelists and what AX initiatives each of your teams are working on. Beginning with Ohira-san, please. Yes. Hello. I am the Development Unit Lead, Ohira, in the Media SBU. And I'll talk about the AX steps we've taken thus far. You can see the 5 E's on screen right now. At the top, envision, which is a definition of what we're trying to achieve with an AX in the first place. In our organization, we want to maximize the product value offering, and as a development organization, increase development productivity and increase product quality. And the AX is to be used to that end. That forms the backbone of our initiative. Then we build the environment, actually apply it, and share anything good that comes out of our efforts with one another, and perform organization-wide awards in order to promote AI activities, and then measure organizational output and bring our outcomes gradually closer to this vision. Those are the steps we've taken so far. And I'll talk a little bit about our levels here at the end. The first level at the top is what happens before working on an AX. Optimizing current process efficiency. So for example, let's say you have a lot of meetings and you don't have enough time for dev. There's a lot of systems, which makes maintenance hard. Even if you implement AI in such a situation, effects would be quite limited, so you need to be thorough in eliminating waste before any of that. Then given that, you implement AI into your existing workflows. And in doing so, there's awesome things that happen and many limits that we ran up against. And so based on that, you need to redesign the dev process as a whole and standardize as an organization, which is what we did. For example, we also have spec and test-driven development implemented in our organization. But the most critical point is the foundation of all that, engineering practices. For example, properly breaking down responsibilities, limiting impacts through phased implementations, reviews, and things like that, making sure that AI does them properly, and then self-verifications, verifying whether or not they are actually doing that properly or not. These are the types of organizations we built, and I believe that will connect us to the automation we're talking about here. Number 4 is scaling to AI-centric maturity, and we have not yet reached this stage. To close, I'll talk about the challenges we faced in our initiatives. Number 1 is the accumulated pull requests waiting for reviews. Indeed, there were a lot that piled up. Even if you implement AI, do you get immediate effects? No. It's very important to trim down those bottlenecks when they happen. This is important for us. Number 2, in attempting to improve efficiencies as this is a significant pressure. You fill your empty time with tons and tons of tasks and lose opportunities to learn. This is something people on the ground told us. And then, once AI starts producing output, our learning opportunities get lost faster and faster. I think this is an extremely critical issue which needs tackling as an organization. And 3 is communication between humans is slower when compared to AI. So this is an issue. So the thought is we might need to revise roles and responsibilities slightly, and this is happening as a discussion in our organization. Thank you. That's all from me. Thank you. Next, Kobayashi-san from Commerce. Sure. I'm from the Shopping SBU and the unit lead for the Product Development Unit 3. Kobayashi here. Thanks for having me. I'll talk about the AX initiatives we've done and what we've done in the Shopping SBU, the organization I belong to. First, I'll talk about the 2 lines you see on screen at the top. Number 1 being the first initiative that we worked on, which is about building a knowledge database. So, AI development, not even just development, but all AI optimization initiatives need to be spread throughout the organization, which is what we focused on here. And this is something that goes to our great efforts to foster relevant culture here. Those of you from LY might have heard about this, but we always say nice tackle and things like that in our morning all hands, etc. So what is this all about? In using AI, you're able to improve on various different issues. But you need to, there's a lot of improvements that don't get to the heart of the process. You make something, you implement, you can use this immediately. That's not something that happens very easily. You need to try doing something fundamental like that. But those tries are quite difficult. And try, meaning how you score in rugby, similar to a touchdown in football, is the heart of this initiative here. Let's try. Number 2 is code generation, another focus of ours that we have begun. And what we've started doing is looking into how much AI has been used in pull requests. People write into those requests how much AI was used, and we visualize that data. And we began this originally from early 2024, and 40 to 50% of those requests are now made by AI. So indeed, there's been progress. However, at the same time, despite the AI making this many pull requests, we have the main merge count, we have the 4 keys, basically the number of deployments, and there have not been any significant changes in these metrics yet. This is an issue. So we need to find a new breakthrough in order to accelerate improvement here. Next, I'll talk about points 3 and 4 in parallel. We also are trying to strongly promote AI-driven development, and these are initiatives on that point. One critical thing we think relates to this is how you get AI to give you the information you want and what information you have to give it to do so. I think we need to be creative in this regard. And to that end, building an information platform or something like that is another thing we are trying to do. And I'll talk about the details of this on the next page. But those are our initiatives. And lastly, standardization. I mentioned knowledge sharing at the beginning, which we have been working on. So these success stories being rolled out and shared laterally and applied on a standard basis to this workflow, this work process from a bottom-up basis is another initiative we have in mind, in place. Of course, there's various issues, which are those indicated in these bullets. I'd like to add some context about the information platform I mentioned. Why did we need this? We have this service, Yahoo Shopping, that I'll mention here. Every month, the number of active source code repositories is over 1,000 or so. That's the scale of this service. And the size of this service, in terms of specs, what's in the source code, etc., all being thrown into an AI context for dev and for design, given the current level of AIs in the world, is not possible. So, as you can see in the middle of this slide here, we have this low-grain information, so basically manual level information that we give to users could be retrieved across boundaries. And in order to get higher grain information, if you turn your eyes to the bottom of the slide, in terms of domains, you can get close domain information. So here we have the search domain, and you can pull information out of the search domain specifically. And we've built a platform in which you can retrieve information in this way, MCP'd it, and it is now available for call via Claude, etc. And those are our initiatives. Thank you again for having me.
Thank you. Contents and membership. Son-san, over to you, please. We'd like to share how we promote AI. We have already introduced AI from 2023. We are at phase 3 at the moment, promoting our activities. In our first phase, we established a governance to make quick decisions, and we have developed application so that we can run maintenance. So that's the platform we built. In the second phase, based on the first base platform, we promoted automation, the support tools for BM and automation and so forth, or automating the monitoring activities. Having said that, we also found challenges, so therefore we are now at phase 3. If I may share phase 3 in simple terms, DLC, AI native, and also turning the entire life cycle to AI native. Let me also touch upon the issues we faced. In phase 1 or 2, we had various activities like planning and release, and we tried to introduce AI in many of them. We saw some gradual improvements, but in the entire perspective, still, we had issues around lead time. So the entire picture didn't change so dramatically. So that is the velocity paradox of AI. If I may talk about the root cause, it's a handoff within the silo or function. So it's a problem of edging. R&R is clearer as the organization grows, but in the AI environment, when the phases change, it requires a clear-cut handoff. And then there is an increase in lead time or loss of context. So if I may share in more details, I think we can split into 3 things. We have found 3 causes. We concluded that all rooted to handoff. So at the time of planning, there is a wiki page, a PPT to share the plan to the developer. The developer interprets the plan and then design the activities. And then when QA happens or a release happens, there is a handoff. So that is when there is a loss of context or increase of lead time, and there is a gap in decision making. So how can we close and solve this issue? In our discussion, AI native development cycle or BiBOP is the combined project we worked on. If I may share the concept, spec development, BiOps are put together and combined. Single source SSOT is developed and using the pipeline that's fully systematized. Through the memory number, we save the knowledge and context to make decision. This is still in development at the moment. We receive instruction and will be a standardized domain to be implemented. Thank you. Thank you. Koike-san from Line Plus, last but not least, the floor is yours. Hello, everyone. Line Plus Corporate Fellow, and I'm in charge of the advertisement of LY Corporation. Today, I am sitting here as a representative of Line Plus. Line Plus basically is to promote the projects with the LY Corporation. So it's not so different from the 3 earlier projects, but as we follow the top-down strategy, we also have our own Line Plus strategy. And through this, we strengthen our individual AI capability and increase the use as an organization. I would like to talk more specifically. First, about AI newsletter. We update the latest information in this newsletter and understand the individual needs of AI. And then through AI Tech Up, we also provide training and lecture that can be practically implemented. And those who listen to the lecture could easily implement in their day-to-day life. So this is the individual level or capability building. But if you look at number 3, this is suited for the organization. So we select the evangelist by organization. Why by organization? Because the organization have different context and environment. So we didn't want to implement across the board, but to make sure AI is implemented according to the context of the day-to-day life. So when we implement AI on our task and organization, there are some challenges, of course, but in order to solve them, we have a one-on-one consulting with evangelists to ensure that the real-day problems are fully supported and solved. So these are the 3 cases we would like to introduce. First is the line domain. From the plan to development, we have a flow of activities. We use agent and automatically propagate the plan from the upstream to downstream. And when we do the development, we have the design documents and review the documents and start development. So that's the planning. The planning, then development. That's the sequence of activity. Once the development is completed, before human reviews, we have automatic verification using 6 agents. And in the case of Ray projects, when we develop a feature, the feature flow pipeline is automated, generally speaking, and if it's 90% per project, most of them are AI developed, and the remaining 10% is reviewed by human manually, allowing us to accelerate and expedite our development. In this, we develop an AI guide. We have already accumulated 5 AI guides so far. So it's not leveraging our knowledge. We are making sure that we can accumulate our knowledge. In a global B2B project, we have, B2B office, we have a project. 100% of AI coding is enabled. So AI is almost fully coding. We talked about SSOT. We mark them down and manage all SSOT. So AI could use the data at any time. This is not just a specification documents in the planning phase, but at the execution phase during projects. We have a project memory, what happened during the project, also managed in SSOT. So this can be shared among members, but could be shared with AI too. So we try to incorporate the most amount of data there. So these are the real experience and real challenges we experienced so far. One is the variation between individuals to leverage AI. Even though some individuals are good at using AI, still there are a long way to fully utilize as an organization. So we do not believe that a full AX transformation is completed. When we do AI, there are some areas where process optimization could not be achieved. So we not just want to use them as tools, but we need to redesign how we work so that the entire process is incorporated. And as the keynote speech, Yuvin-san mentioned, project development alone cannot solve everything. Like second line security, PR, legal, all activities. In a large-scale company, these functions are also important. So we need processes developed suited for AI. Otherwise, it will be hard to promote and make progress in the project. So developing the process will be the next target.
Thank you. Right, thank you. Wonderful. The LY Group Corporation Group is a huge enterprise, so there are various AX initiatives and challenges as well. Lots of different colors. So, next theme. How to measure the impact of our AX initiatives is the next thing I wanted to ask about. Kobayashi-san from Commerce mentioned briefly that even if there's more code being generated by AI, this doesn't necessarily shorten lead times. And even across society, in development teams, yes, AI development is making progress, but people are unable to judge how much dev productivity this has led to. And I think this is a comment and an issue that's often faced. So, Sonu-san, you also mentioned lead time. Could you give us some thoughts on this? Right. So there are various different metrics that we use to measure AI productivity improvements. In dev, this is lead time, which is very important. Obviously, that's not the only metric we use. The level of the achievements and productivity that you can make with low resources is important as well. So labor and other AI-related costs are important to measure as well. And also, lastly, there was mention of how much contribution can be made to the company, to the organization, which is very important to us as well in our office initiatives. So the knowledge and know-how that comes out of our projects and how much of that can be returned to the company is something else that we would like to measure with various metrics. So what specific initiatives and attempts at improvements of those numbers are you making right now? Do you have some examples? Right. Before I get into that, I'd like to speak to the personal side. So our organizational goal is tripling. And of course, it's important to improve individual functions in order to hit this 3x goal. However, we need to reduce lead time between these individual features and place them in parallel. And we hit that 3x figure by making these processes move in parallel. And so we talked about vibe ops a little bit a moment ago. And building this in order to improve the life cycle overall is another initiative we have. I hadn't mentioned it yet, but on the next page, or rather in the next stage, I wanted to actually measure the impact and improvement more specifically. 3x is incredible, but 10x is our goal. So indeed, we have a long road ahead of us, don't we? Yeah. Of course, we're working on these improvements, but If 3x continues for 3 years, then we could perhaps hit that 10x figure. So we're going to keep working. Looking forward to it. Next, Kobayashi-san, I wanted to ask you, you mentioned a moment ago that you have very similar issues. Any thoughts here? Yes, thank you for the question. Indeed. In the exact same way that was mentioned, there's this lead time issue, and also there's no increase in the number of merges based on pull requests. But the bottleneck we have right now is reviews. Any issues that we have visualized, as long as we take some sort of action against them, I think we'll be able to make that improvement at some point or another. So we're making that try right now. The question is what happens after that? And what happens with these issues, which indeed will pile up if we are unable to visualize them? So when we think about what that's going to be, recently we have Claude Code, Codex, etc., which are used for vibe coding. And if you were just to make something, then you can make something very quickly through this vibe coding. However, within this aspect of product development, you need to think about why there's no increase in the number and velocity of merges. And that's because we have to provide very important features to our users. So putting together these features is one thing. The other is in putting together a product, we need to provide something that is high quality. And we're unable to guarantee that at the same velocity that AI does, which is a pain point for us, disabling us from increasing product development velocity. So if we look at quality and velocity, how do we measure these aspects? To be perfectly honest, that's not something we are sure of whatsoever. What we could measure and what countermeasures we could take to improve upon that, I think, is the next thing we need to consider. Right. Ohira-san also mentioned pull requests briefly, so I'd like to hear your thoughts here as well. Right. So for pull requests, at the end of the day, the impact on the bottleneck is that they can impact throughput, etc. But they're also very visualizable. So you could visualize what's happening there and say you have phases such as awaiting review, finished review, awaiting merge, and make a visual representation of how many are waiting where, and then make improvements against that. Also, if the pull request is big, there's all sorts of perspectives that get mixed up in there, increasing cognitive cost, which deserves addressing as well. On the other hand, stepping away from implementation, Kobayashi-san mentioned a moment ago that there are lots of areas there aren't metrics being taken for. Lots of people are using a ton of different tools. And how you understand those bottlenecks and resolve them is probably where the next problem is going to lie. I see. So not just for development tools, but all internal tools need to be observed, perhaps, right? Okay. Lastly, I'd like to ask about what things are like at Line Plus. Sure. So I want to talk a little bit more about the bottlenecks. Actual development is really accelerating. Source coding is accelerating. And also, small project teams are driving projects using AI. And that speed of drive indeed has accelerated, and I do feel this. However, in terms of results, not only small projects, but big projects need to be part of this journey, and these need to integrate with one another, which is a huge pain point for us. We talked about SSOT completion, but when integrating with other teams, you need to rewrite all of the specs. Then you'll end up with two sources, which is a problem. And also, when communicating, it becomes unclear which the original source document was. And indeed, that creates this problem of not being able to control AI output. And so, in order to level ourselves up, we need to run these processes in parallel, together, and improve them together. Okay. I'd like to move on to the next question, but I think it kind of segues naturally from what we were talking about. I'd like to talk a bit about quality. So, in AI activities spreading and their output increasing, so for example, the number of AI created pull requests increasing, we need to process these quickly, less lead time, not improve. But at the same time, there's this dilemma of needing to ensure quality. And I'd like to ask first Ohira-san about your perspective. Sure. So ensuring quality, this issue of ensuring quality is something that indeed we have done thus far as well. But through AI acceleration, it's becoming a new challenge. We reviewing and verifying everything in perfect alignment with AI acceleration is not realistic. So to some extent, we need to leave some things to AI and focus our own efforts and judgments on the more critical areas. I think that's where we are. But the situation is, it would be great if we could do that as soon as we implemented AI, but that's not the case. So we need to build that environment ourselves. And how we do that and what requirements we fulfill with AI and how we can build that automatic verification environment is going to be important for quality assurance moving forward.
So the critical points require human. So what do you mean by critical points? Where would that be? Like life, asset-related things or personal information-related areas. We can't completely leave the task to AI. I think human intervention will be necessary. Okay, so commerce also involves money and critical information. How about that? Absolutely, yes. Like money or information leakage and violation. We do have sensitive information stored, so I believe there is a phase we need to thoroughly verify. I may want to go a little off topic, but recently I tried to think using paper and a pen. And why do I do this? It's because when we develop using AI, we receive enormous amounts of input. And if we just read through and review, it sounds very plausible. So, but to be fully convinced, we want to lower the gear of thinking. So I think we need paper and pen to think. So that's the attempt I'm working on. And through this endeavor, through the development phase, even though we utilize AI, can we run from end to end? I don't believe so. Maybe we need to slow down the velocity. Sometimes we need to expedite the velocity. And I think we need to switch those gears. The switching the gears is the important point. So for AI-driven development, we need to have the check gates and have a moment to contemplate and make human intervention and decisions to go ahead. Where is the check gate? One is about quality. And as I mentioned at the very beginning, it's very important to think what we are developing. So the early phase of development would be important for human intervention, looking into the necessity and significance of development. Absolutely. In the content, it's true, you handle personal information, sensitive information. What do you think about that? Yes. In our team, we are in a similar situation as the two earlier speakers mentioned. When we have a project AI-based activity, we have gates by stage and have human intervention where necessary. And if I may add some comments, AI is prone to failure or errors. It's inevitable. So that should be built in our assumptions when we drive development. So in our CNM, QA, release, and monitoring, QA and monitoring after release, post-release is the area where we place more importance on human. We look into automatic recovery and the ways we distribute to enhance the stability of our services. So Son-san, you talked about QA, quality assurance, and I think it was very interesting that Kobayashi-san mentioned that the early phase, early development phase. Now, in the material, you were able to minimize human intervention to 10%. Would you kindly elaborate on the quality aspect as well? So 90%. So AI can shoulder 90% of the work, and the remaining 10% is the review by human. Like in the case of screen, it's very hard for AI to review, so human will review manually to confirm the functionality has been implemented successfully. So in the case of projects, AI will do the activity, and there is a 6-stage quality check. We have an agent to run this 6-stage quality check. And there is a process for humans to review that the AI have done the work correctly. So it's true, AI makes failure, but human also makes failure. Depending on projects, there are a predefined specification, and we develop a test case according to the specification and test AI's coding and confirm there's no issue to finally assess that the coding has completed. That's the quality control we have in place. AI could possibly cause hallucination. So one representative example is that we ask a document review. Sometimes AI would generate text on their own, and that has been an issue. So what I've done, if there's a word that I personally do not know, I ask AI I make a prompt for AI to refer to the dictionary and not use any words outside of the dictionary. And if it's a word unknown by AI, it will specifically note that AI cannot decide accurately. And those areas are where human would need to review and check and add in the glossary or a dictionary. So these kind of harnesses would be necessary to implement in order to enhance the quality. Thank you. That was a very interesting topic to hear. Before we leave it to human, I believe before we leave to AI, a human used to take that responsibility. And if we have a glossary and a very accurate glossary, we will be able to make the requirement documents, and the quality of the documents would enhance. So I think that would be a similar situation. I would like to move on to the last question. First one. The situation and challenges for AI implementation in large services. Ibin-san mentioned in the keynote speech as well. For a brownfield development, it's quite challenging, isn't it? In Line and Yahoo, the code base is enormous and significant. And for Line service, it's been 30 years since its launch. So the existing service is already incorporated in the specification, and it's an accumulation of the long period of time. So these context that's been utilized for a long time is hard to leverage AI. So I'm wondering how you overcame these challenges. We would love to hear. I think there's a lot of people who are interested in this area. In the commerce, I heard you developed an information platform. Would you kindly elaborate on that? Yes, the trigger was when we started the AI-driven development. As I mentioned, for the services, we have more than 1,000 repository in our services. Even though we start from the design on making changes to a certain application, we don't know what information we need to feed into the AI. Because if you put all the information, that will overflow. So even though we give the source code for one repository, it will overflow. So it wouldn't be successful for development. So we needed to make a decision what not to feed into AI. Otherwise, it would be hard to generate. So that's the reason we came to develop this. So this is the upstream, like basic design. When we design the application, we need the course level information across the different application. So we needed that mechanism, and then first feed that information for design. And once the design is completed, let's say there is a merchandise screen, we will give more information and ask the AI to work on detailed design. And then finally, we have repository level or information fed in. So that AI could refer to that repository level. So it's like a 3-stage or perhaps 4-stage level, or with different granularity of information fed into AI. So that's how we approach the AI-driven development.
However, there are indeed still issues here as well. We're moving forward with this initiative, but looking at the way the world's going, indeed, teams and organizations with great AI-driven development velocity speed are all over the place. But we as an organization are different in terms of scale and history, how long we've been around. And so we need to build an environment in which we can try at that scale, or else we're going to lose. And even in our services, we do have smaller microservices that we built in which we design, dev, and operate, and have tried this out. And we want to build success stories there and roll those out with speed, or else we're going to lose. So I think we need to build the systems that enable that. And these are all things that we are thinking about and studying, but if there's anybody sitting here on stage with examples of having succeeded at that, we'd love to hear it. Right, it's not an example, but since you mentioned microservices, I'd like to talk a bit about them myself. So, in CMD as well, we worked on service improvement thus far, but in our next stage, we want to work on games, music, and talk size services. So basically apply those improvements to our bigger services. And the thought we had in doing so is previously we were talking only about development methodologies, but architecture itself of our services needs to be improved for AI. As you know, context size is limited in the for AI. And of course, we have this issue of overly large contexts. Whenever there's a failure or a mistake that happens, we need to minimize the scope of its impact. One example of this is a microservice architecture. All services don't need to be incorporated into a single context. All these services which are adjacent to another could be incorporated into a context adjacently for dev and development. And the client size and front end, etc., have various other methodologies, but we need to improve the architecture as a whole in order to address this issue. Yeah, so the earlier speakers just talked about microservices. I'd like to address things from a slightly different angle. Let's say we have a very small scope in which things are working well, but at scale, things don't go well. So for example, if you're looking at creating a predictor for advertisements, if you make a proper model, but then there's an issue of like 2 clicks happening, then the CTR would double, which means that it wouldn't be valid as information. And this is hard to detect within a single microservice. So using AI to connect smaller services for a bigger service means that end-to-end monitoring is more important than ever. It might start looking like a black box, but connecting the front to the back and looking into what normal data is needs constant monitoring. And it'd be great if we could have AI do this. And when a problem becomes apparent, you zoom into where that might be, find the component that is problematic, and detect it as soon as possible. And that's the kind of technology that I think we'll have to look more into moving forward. What about the media side? Right. My thought, listening to all of that, is that microservices themselves have been a philosophy for a while. But a higher frequency of changes in which we want to minimize the scope of impact is the other philosophy here. And when humans don't do this, but AIs do, this will change the frequency of update, and I think that could lead to further improvements. Thank you very much. We are getting ready to close, but I'd like to get a short comment from everyone, because those in the audience are about to launch AX-related initiatives, I'm sure. So if you all have a short message for our audience, please. And I'm sorry for the very rough question. No worries. So in what we've talked about today, the roles of engineers and how they're going to change moving forward is a discussion that's being had throughout society. But there's still a lot to think about, is my thought coming out of today. And so, what do we need to do to protect as engineers? Is another big question that is important in making big achievements alongside building AI-related knowledge. And I hope we can accomplish this together. Sure. Then I'd like to send a message to the engineers listening. In this era in which generative AI has come up so quickly, I think a lot as an engineer as well. What's going to change? My conclusion is probably nothing. So, what engineers have been called upon to do historically is get a lot of high-quality input and create output based on it. That's been the case forever. And I don't think this is going to change dramatically moving forward. What's going to change with the advent of AI is we'll be called upon to act with higher velocity, which is going to require practice, drilling. You can get all sorts of huge volumes of information from AI in your day-to-day, and you need to continue practicing, taking that input and creating good output based on it. So let's do that together. Right. Rather than the technical side, I want to speak about how to feel. In the age of AI, there's a lot of change happening every day, and our attitude towards our work and our technology will be changing as well. AI will continue to be a huge trend. And engineers love being agile, right? Try something out, and if you make a mistake, then find another way to get around it. We need to take on new challenges actively to succeed in the AI era. So, in my development, experience, there were a lot of people who were called good developers when the specs were finalized. In the AI era, we'll be able to develop these specs more quickly and better. So I think we're going to have to cover a broader field, especially for reviews. We can't just look at the specs and then the code. We have to think about why that code, why those specs are there in the first place. Developers need to be able to be more considerate of the design stage of things as well. Thank you. So, listening to what all of you have said today, development is indeed significantly changing and will continue to change rapidly. So, we need to ride this so-called big wave as you are enjoying your AX initiatives. And I hope today provides some inspiration for those of you who have listened in the audience. Thank you for your participation and your attention.
Hello. I was very nervous, wondering what I would do if no one came, but I'm very grateful that everyone in the venue has gathered. Thank you. It's time. So, my name is Nishimura from Line Yahoo, and Onishi will be presenting on why AI doesn't reduce workload as much as expected, the limits of human-in-the-loop and AI-ready business design. Thank you. Today, taking the task of product patrol for Yahoo Auctions and Yahoo Flea Market as an example, we will discuss efficiency improvements using AI. I will be discussing the challenges in business structure that became apparent beyond the legal aspects, and what we are currently doing to overcome them. Today, I'd really like you to take away that simply adding AI to existing operations is not enough to truly transform them with AI. Now, I'd like to briefly introduce myself. My name is Tomohiro Nishimura. I am typically assigned to the security department, specifically focusing on content fraud prevention. Within that, I am the product owner for a no-code AutoML tool called AutoLearning. Okay then, from you too. I'm Kanako Onishi, and I will be taking over for the latter half of the presentation. I am usually responsible for AI and mechanization in the CS Patrol and monitoring areas, which I will be discussing today. Thank you for your time. We have been advancing the introduction of AI, such as HiMat, for patrol operations since around 2020. Today's presentation will cover the initiatives we have built up over several years through a trial and error at the front lines, working together as tool creators and users like Ms. Onishi and her team. Today's session is divided into two parts, the first half and the second half. In the first half, I will talk about how AI implementation has changed our operation. We will look at what improvements were made by introducing AI into product patrols and where the limitations were. In the latter half, Ms. Onishi will discuss how we are redesigning our operations with AI in mind. To overcome the limitations we saw in the first half, we will be introducing how we are reviewing our operations, rules, and the roles of people. Now, I would like to move on to the main topic. First, I would like to briefly explain what Product Patrol is, which I will be discussing today. Product Patrol is one of several initiatives to maintain public order on Yahoo Auctions and Yahoo Flea Market. Specifically, people check 24/7 whether products violating guidelines are being exhibited. There are two main aspects to this patrol work. First, identifying suspicious items from the several million listings that appear each day. And there are these two steps, checking the found items against the guidelines and making a judgment. Both of these are quite difficult tasks. For example, from the perspective of finding them, the number is certainly very large, but the difficulty lies in keeping up with the daily changes in violation trends, methods, and phrasing. And from the perspective of judging, for these products that have over 300 criteria, where exactly there is the difficulty of discerning whether or not they are regular. We will now explain in 3 stages how we have incorporated AI to address these two different challenges. First, let's talk about what patrolling was like before the introduction of AI. First, in terms of detection, we identify suspicious items by using several thousand queries with conditions such as keywords. The products found. It's like the image in the screenshot on the right, but I couldn't show the actual product this time, so I brought it as an image. It was something where we would make judgments while checking the product information and the contents of the standard document on the review tool. In terms of finding things, what kind of queries should be set to find what we're looking for, and also, for the items found by those queries, the criteria and perspectives for conducting reviews were heavily dependent on the experience of each individual in charge. In particular, detection using this query sometimes results in false positives, where something is caught even though it's not problematic, simply because a keyword is triggered. Also, there are a considerable number of queries, so the maintenance burden was very high, which was a challenge for the team. So first, we started by trying to do something about this detection part, the finding part. This is about AI filtering. Until then, we were doing things with queries, but we started by training a classification model using past patrol result data to replace them with AI. However, by replacing it with this AI, we are now able to detect not just keyword matches, but also the content and context of products, which has significantly improved our capabilities. The detection accuracy has improved. Also, we were able to reduce unnecessary complications. With this, the detection part has significantly improved. What we also did, in addition to this, we also provide support at the entry point of the decision-making process. We are now zooming in on the top 3 reasons for violations in similar past products, and as you can see, we present them to the person in charge, indicating there might be a risk from this perspective. It's an image that we'd like you to use as a starting point during the actual review process. This improved the initial stage a bit, but whether these 3 perspectives truly apply, or which specific parts are problematic, still depends on the judgments of the people in charge. Past experiences and we were heavily dependent on them. So we took another step, and what we started by delving into judgment support was this AI pre-screening function. In the era of filters, we only focused on suspicious items. Previously, we were only able to identify items, but with this pre-screening, we can now specify which part of the product violates which standard. What we're doing is very simple. We're inserting an LLM into the AI filter section I just mentioned. This means that AI performs a preliminary check before humans review it. So, as shown in the figure on the right, the results of the pre-screening are returned. We also include comments on how AI reviewed this product and links to related standards. Also, surprisingly, humans tend to overlook. We also highlight keywords, for example, areas that should be carefully reviewed. The sample we are showing this time is a fictitious one, which is a uniform of a shipping company. As you can see when you read this, at Yahoo Auctions and Yahoo Flea Market, the uniforms of shipping companies are. There's a risk of people misrepresenting their identity and entering buildings simply by wearing it. So this item is prohibited from being listed according to the guidelines. And that information is written in the comments, and the patrol staff can review it before proceeding with the examination. With the introduction of this pre-screening, the people in charge now have specific points of view that they need to confirm. As a result, we were able to lower the bar in terms of judgment in areas that were heavily dependent on the experience of the person in charge. So let's look at how patrol has changed. Our review efficiency has dramatically improved. The review efficiency at this time is as follows. This refers to the percentage of items that actually led to deletion or other measures after being reviewed by a person, like a batting average. When the query itself is considered as quantity 1, with the introduction of the AI filter, it's 26 times. With the AI pre-screening, we were able to achieve an efficiency improvement of 50 times. That's what I think. If efficiency increases by 50 times, we expect the work time to be reduced by 150 pounds. The reality is not that simple. When we opened the lid, we found that it didn't change much. This is the result. So why? Even though the efficiency of the work increased to this extent, did the time required for it not decrease? I would like to touch on that one last point before concluding the first half. This relates to what I explained earlier. Issues were discovered in both the finding and judging stages. First, regarding the detection side, with the improvement in AI accuracy, the amount of human review required has dramatically decreased. However, on the other hand, it's even more difficult. AI has become able to find things that are difficult to judge, and those are now being passed on to people. Therefore, while the number of items to review decreased, the proportion of items that took a long time to judge increased, which is one of the factors. Another point on the judgment side, as you saw earlier, the AI pre-screening comments are very powerful and effective. It significantly aids in making judgments. However, I believe you all feel the same way. Just because AI says something doesn't mean we can act on it directly. So in this case, there are things that cannot be directly deleted. In particular, the decision to remove a patrol must be made very carefully. So we started making more thorough decisions, including AI comments. With the introduction of AI, we have reduced the amount of content that humans need to review and are now able to provide specific decision-making criteria. As a result, people are now able to make more careful judgments on more difficult and riskier products. However, if we continue to assume that people will ultimately check all AI results, there will be a limit to how much we can reduce work hours. This was the limit of human in the loop that we encountered in improving operational efficiency. From here, I would like Ms. Onishi to talk about how we are trying to overcome this challenge. Ms. Onishi, please. Now, Ms. Onishi will speak. Now, from Mr. Nishimura, we have been making various efforts to improve operational efficiency by extensively utilizing AI. As a result, the volume of work itself did not decrease. Why is this the case? How we can reduce it? We thought hard about it and realized that a significant change was needed. That is, previously, we are now introducing AI into our existing patrol and monitoring operations. We have been continuously considering how to improve efficiency. However, what was actually truly necessary was that is not the case. How to? By changing to an AI native workflow, AI can make judgments independently. We realized that we needed to fundamentally transform our workflow so that human in the loop would no longer be necessary for final confirmation. Therefore, we temporarily discarded the existing patrol operations. We decided to reconstruct the patrol operations to be the best possible in a world with AI. AI, you see, when we considered what AI native patrolling would entail, yes, as shown in the figure on the left, and areas that only humans can handle. An area where humans and AI work together. We have been trying to increase the areas where AI can work together as much as possible. What we aim for next is, the question is rather how to create areas where AI alone can make judgments. One important point is, this does not mean that we are entrusting everything to AI and going fully automated. We need to clarify which areas do not require human review. As a result, to help us move into more difficult areas, or areas where we're sure people are involved, we're looking for areas that AI alone can handle. And we thought about expanding it. When we want to increase the areas where AI alone can make judgments, what's important, of course, is the locus of responsibility. Therefore, through these initiatives, we have also carefully considered how and where to place this responsibility. Therefore, to make this possible, of course, AI can also make mistakes, so we built a system that allows for recovery even if the AI makes a mistake, ensuring safety and security. On top of that, we created a situation where we can confidently say, so it's okay for the AI to make decisions. We decided to build this in a way that allows people to focus on tasks that only humans can do and on areas that require human oversight. So, with this policy that AI takes responsibility for decisions and AI makes the final decision, when we try to do various things, challenges arise. The very first challenge. What is this? This is it. It's about getting approval from stakeholders. Since this monitoring and patrol work will fundamentally change the nature of the work itself, the impact will be enormous. This will be a rather bold decision, so we need to ensure that stakeholders understand why we must aim for this. Therefore, we have two main points for that. We took the code. One is, this ties in a bit with the first half. We clearly visualize the point where there are limitations when humans intervene. I mentioned that the efficiency increased 50-fold with the introduction of SNS AI, but this is not because we tried a little. Rather, we made numerous attempts and various adjustments. We pushed it to the point where we can truly say that was the limit. And then, I believe they still exist. It is absolutely necessary. Humans are more capable than AI and the quality of the work is high. Many people felt that way. Whoa. Therefore, there's a concern that entrusting AI with patrol duties might degrade the quality. I also needed to answer on paper. Regarding this as well, it is very challenging, but we heavily check a large amount of human work results. When AI does the work. When people do the work. Whether humans truly offer higher quality. We conducted a verification and showed that this was definitely not the case. This patrol duty is extremely difficult. Also, the terms and conditions, there are so many. I thought it was a task that humans really couldn't do. As mentioned. After all, even humans. It did not mean that the quality was higher than AI. And one more thing, we convinced them that AI could perform high-quality patrols, but there was one more thing we had to explain. Then, why not just AI-ify the current operations as they are? We also had to answer the question of whether it was acceptable as is. Regarding this, why is this current task, not AI, ready? There are a vast number of operational instructions intended for humans, and we thoroughly examined them in detail to identify and document every aspect that is not suitable for AI and why. Let me elaborate on that a little. The reason we couldn't AI-ify the current operations as they were is, in a word, because the current operations are designed for humans. This means that it was often difficult for AI. For example, the operational instruction manual, if this is read by a human, even if it's somewhat ambiguous or not fully written out, they can compensate for it with their past experience. Also, if there are operational rules not written in the instructions, a human can check with a colleague next to them or a supervisor. However, if you try to have AI make a judgment, it doesn't work that way. This means that we must clearly articulate what criteria define a violation and to what extent. in a way that AI can effectively process. This is not at all to say that the on-site staff are at fault or anything like that. It's just that humans were able to compensate for it and that it had been working until now. Since the objectives are completely different, which is how to make AI native from now on, the idea is to make tasks easier for AI. There were 3 major challenges hidden in the work instructions for humans, so I will introduce them to you. One is ambiguous phrasing, or that there's no priority in the rules. Also, in terms of how it's written, there's categories unrelated to the listed item, for example. For example, what does unrelated mean? This area is a problem where definitions are not yet established. Next, it is a standard based on implicit values and local rules. In reality, this was actually the biggest challenge. The rules are evolving uniquely on site. Therefore, although not explicitly documented, there were actually many cases where conditions like actually this condition is also necessary applied. Finally, the judgment process is extremely complex. This, of course, also increases the difficulty of the task, and if we were to replace this with AI as is, the AI would also have to follow a very complex procedure. So in order to improve its quality, we believe that the process must be made as simple as possible. We address these issues hidden in human-oriented tasks one by one and transform the tasks themselves into an AI-ready state. It was a very tedious task, but I believe this was actually the most challenging part and the biggest hurdle we had to overcome. Now, I would like to briefly summarize what AI-ready business design entails. When we say AI-ready, people tend to focus on using generative AI, but I believe this is not just about refining prompts. AI must be able to make autonomous decisions and, moreover, be sustainable in its operation. We have 5 points that we always strive to uphold. The purpose and goals are clear. The judgment criteria have been clearly documented. The necessary information is structured. Exceptions and boundaries are defined. And the workflow is simple. To meet this, we redesigned our operations and prepared prompts accordingly. From here, I would like to touch a little on prompts. This is an instruction for the AI. The prompt in this context is not merely a command, but can be considered the very essence of a business judgment. Therefore, this is a very important task. First, the challenge was this enormous set of regulations, and for people, the business instructions, we don't give them all of that enormous amount of information, but it was a situation where we had to make choices and properly provide what was necessary. Therefore, we first divided the prompt into 2 main parts. One is the part that is automatically generated from publicly available terms and conditions. And one more thing, the sentences that describe the information associated with it. Although people tend to write a lot here, it's really about what is truly necessary. We picked up from the instruction manual for humans, and then even changed the border and wrote it down, thus creating a large framework first. Next, we were able to make it quite a bit more compact than the current work volume, but we still need to operate this. So that's what it means. If there are any changes to the terms, it's natural that the prompts will need to be changed. However, the There is no doubt that the volume is enormous, so it was important to consider how to improve maintainability. Also, because it's a very large prompt, it was impossible for one person to conduct all the verifications. Therefore, even if multiple people divide the work, in the end, it needs to function as a single prompt with consistency. To solve that problem, we have this supplementary part. We decided to manage these rules separately, rules common to all categories, and rules specific to certain categories or products. As for the common parts, if multiple people make changes, there will be no consistency, and the same things will be written repeatedly, making it impossible to operate. For common cases, we assigned a small number of fixed administrators and entrusted them with revisions and other tasks to maintain consistency. By creating this state, we were ultimately able to combine all the parts and establish a consistent prompt. In this way, by significantly changing our work processes, we constructed an AI-ready work process. In addition, we also sorted out what would happen to people after this AI utilization progressed. Previously, people would carry out tasks and monitor them. The worldview was that AI would support humans. From now on, under this new workflow, performs the monitoring. Well, people are responsible for operating and improving that AI and for thinking about how to best manage the broader guidelines themselves. We also organized the idea that people would move on to tasks that create greater value, which only people can do. What we wanted to convey in this session was, when we talk about AI utilization, the focus tends to be on introducing AI. However, to fully leverage the power of AI, it is necessary to redesign the operations themselves. Up to now, we have used AI to detect rule violations and to identify where violations occur, using AI in various support capacities. However, as long as the final confirmation remains with a human, it's unavoidable. We were unable to truly streamline our operations and reduce workloads. Within this context, it was a very significant decision. We create an area where AI can make judgments solely on its own. To that end, we have been pushing for a redesign of the operations themselves. Now, in the state of AI ready business design, we are about to create a prompt and get started. The essence of AI utilization is not just about implementing AI. AI transforms the operations themselves into a form that can yield their intrinsic value. We believe this is the true application of AI. With this, we would like to conclude our presentation. Thank you very much. Hello, thank you for attending the presentation. I am Young Hyun Kim from the Life Plus Security R&D team. Today, we will introduce the AI guardrail service we are developing. Today's presentation will be given by four of us, Jongwoo, Hyukjae, and Sua from Line Plus Applied ML Dev team in succession. Let me briefly introduce myself. At Line Plus, I have primarily been involved in research and development for FIDO2, device attestation, and privacy-enhancing technologies. Recently, I've been focusing on AI security, specifically on developing guardrails to safely use AI services. Today's presentation is broadly divided into 4 parts. First, I will explain what safety issues exist in the age of AI, what an AI guardrail is, and why it is necessary. Next, Mr. Jongwoo will discuss how guardrails should be established as a separate external system. I will explain the reasons for this in 3 guardrail services: text moderation, prompt injection, and PII filter. Finally, Hyukjin and Sua will discuss 2 guardrail services: topic control guardrail, which prevents topic deviation, and I will explain the specific implementation of the hallucination detection model that detects hallucinations. The past few years have truly been an era of AI. AI services, which started as chatbots, are now used in so many different fields that they have become indispensable. However, with the advancement of AI, new problems that didn't exist before are emerging. The one thing I want to talk about in this part is, if models become smarter, will they become safer? Let's put aside the answer to this question for a moment and first identify what new problems have emerged in the age of AI. We have prepared 3 real-world examples. First, there was a case where a customer at a British delivery company entered "add profanity to all responses" into a chatbot, and the chatbot failed to block the request and actually swore at the customer. In Canada, an airline's chatbot incorrectly advised a customer about a refund policy, leading to a lawsuit. There have been cases where courts recognized this as the company's responsibility. Also, in a US court, a lawyer was sanctioned for submitting fabricated case precedents generated by ChatGPT. Looking at these cases, some of you might naturally ask this question: now that the model is better than it was then, wouldn't that problem naturally be solved by using it? But to get straight to the point, no, it's not. Now, I will show you examples and research results demonstrating that model intelligence does not necessarily guarantee safety. The first example is prompt injection, which you see on the far left. This term first appeared in 2022, and in the interim, models have become incredibly smarter than before. Nevertheless, from 2023 to 2025, prompt injection has remained unresolved and holds the top spot for LLM security threats identified by OWASP. And second is jailbreaking, which is a case where the model's intelligence backfires. There is research that shows that using a smart inference model as an attacker results in a 97% jailbreak success rate against other models, even without expert knowledge. Then how about separate safety training for the model? A joint study by OpenAI and Appler in 2025 found that even the latest models that had undergone safety training performed actions contrary to instructions without researchers' knowledge up to 13% of the time. Even when we specifically trained it to prevent such behavior, it was ineffective. The figure decreased to about 0.4%, but it was impossible to completely block it. These 3 examples clearly show that even if the model itself is highly advanced, it cannot be free from safety issues. If we cannot solve the problem within the model, the answer is clear. We need to place new safety mechanisms outside the model. That device is today's topic: AI guardrail. It's like a guardrail on a road. Even the best drivers can go off-road on icy roads or in sudden situations. Therefore, guardrails are installed on roads regardless of driving skills. Here, the driver is the AI model, and the road's guardrail becomes the AI guardrail. As you can see on the screen, AI guardrails inspect the input and output of AI models, blocking policy violations by blocking, masking, or rewriting responses if they go against policy. However, there's another point we need to consider here. Even if there are limitations to the model's safety learning, couldn't it be done by specifying safety policies in the system prompt? We believe that simply specifying this question in the system prompt is insufficient. It's like how even with stricter laws, we can't completely prevent all driver accidents. Jo-yoon will now explain the specific reasons why AI guardrails should be operated as a separate external system, not as a system prompt. Hello, I am from Line Plus, and I am Jongwoo Han, and I am the lead. Nice to meet you. This is already my third TechVerse presentation. Last year's presentation, in particular, received a lot of attention, for which I am grateful. It ranked third in the number of spectators. And this year, with an even more important topic, topic control, that we were able to meet you all. Generally, guardrails can be divided into two types: internal guardrails and external guardrails. Internal guardrails are a method of writing system prompts for the primary LLM. For example, you can write it to refuse commands that reveal key information in the system prompt or disregard existing rules. Therefore, the initial setup cost is low. On the other hand, an external guardrail refers to a guardrail built separately from the main LLM. For example, it calls an external API to check if user input is safe before passing it to the main LLM. So why do we need external guardrails first? Let's look at the limitations of using only internal guardrails. First, internal guardrails are strongly coupled with the primary LLM. If safety rules are placed within the system prompt, even normal requests could malfunction due to the influence of the guardrail phrasing. Also, even with the same rule, its effect may vary depending on its position in the prompt, and even small prompt modifications can have unexpected impacts on the entire response. Therefore, hierarchical control separate from the main response is necessary. And there's the problem of performance and cost. If we keep adding rules, the input token will increase, leading to increased response latency and costs. Specifically, since the main LLM is a resource-intensive model, and trusting safety checks to it every time is inefficient. Now, let's look at the advantages of using WebGuarder. First, through WebGuarder, we can reduce costs. It might not be immediately clear how using a separate model can lead to cost savings. Let's look at this diagram. We perform pre-screening of input prompts using an affordable model for guardrails. Through this, we can prevent unnecessary token consumption in our main LLM. Furthermore, external guardrail can be scaled independently of the main LLM, allowing for flexible operation. And external guardrails serve as an operational control layer. First, using external guardrails allows for clearer rejection reasons and audit logs. This is because external guardrails make it easy to structure by which categories and criteria content was blocked. Secondly, because the guardrails are managed separately, it becomes easier to track and reproduce the version or policies applied at the time. Third, it can reduce the replacement risk for the main LLM. Internal guardrails require prompt adjustments when the model changes, but external guardrails, being an independent layer, can maintain the same policy judgment structure. Conversely, when the security policy changes, you only need to update the guardrail without modifying the system prompt. Finally, consistent governance can be applied even in environments that use multiple LLMs. Additionally, external guardrails enable the provision of functionalities that are difficult to reliably offer with system prompts alone. For example, if a service is composed of external LLMs, a separate sensitive information filter is used. You can first detect and mask PII filter within your own environment. Secondly, a multi-layered defense structure can be created. Since attack methods are constantly evolving, applying multiple guardrails separately can build a stronger defense system to counter them. Third, LM judgments and deterministic rules can be used together. For clear conditions, such as date format validation or number range checks, rule-based verification is more stable than LLM. Additionally, external guardrails it can also be used for output verification. We can apply fact-checking to the model's responses and block them if necessary. The related content has also been published on our tech blog, so please check it out. Next, we will present specific examples of external guardrails. First, text moderation. Text traffic may include content that can directly harm users, such as information on self-harm, weapon manufacturing, and sexual harassment. Text moderation detects this and protects users. When developing, the most important aspect we considered was that the boundaries of harmfulness vary depending on the country's culture and the nature of the service. Even violent simulation scenes should be judged differently depending on the context text, such as incitement or requests for weapons, and terror plots. Therefore, our system is flexibly designed to adjust boundaries according to service policies. We used procedural judgment criteria to build the training data. Instead of simply listing prohibited examples, we designed it to apply relevance, feasibility, and cultural acceptability of the content step by step. The prompt injection detection system detects malicious prompts that attempt to overwrite the LLM's system prompt or bypass safety rules. We consider normal attacks in the operating environment. To reduce the problem of legitimate requests being mistaken for attacks and blocked, we build an automated workflow based on multi-agent. First, the main agent identifies the experimental goals and test categories, and then creates sub-agents for each category to assign tasks. The sub-agent creates realistic virtual test data and tests it against the guardrail model to identify false positives and false negatives. We repeated this process to identify false positive patterns where legitimate requests were blocked and reused them for model training. As a result, we were able to maintain attack detection performance while significantly reducing false positives, and we gained the flexibility to respond to new attack patterns by simply adding category specifications. If you would like to know more about this content, please refer to the tech blog below. PII filter is: we detect and mask personally identifiable information included in prompts. Now, from a data model operation perspective, I will explain how we enhanced our PII filter. First, from a data perspective, we consider the meaning more deeply than just the simple format. For example, a phone number, even if it looks like a phone number, can be seen as a contact method, but in the context of remittances, it may need to be identified as an account number. To this end, we combined various personas, such as age and role, and multiple scenarios to create realistic test data. From a model perspective, we precisely detect the location of personal information by applying token classification methods such as BioES, which is used in named entity recognition. In addition, we are developing a dual head structure to detect personally identifiable information defined by users. From an operational perspective, we primarily use a light classifier, but for ambiguous or complex inputs, we used LLM fallback to reduce latency. Next, Hyukjae will explain topic control guardrail. Konnichiwa. Hello, I'm Hyukjae Jang from Line Plus. For the next 6 minutes, I will explain what topic control is, what challenges we face during its development, and how we resolved them. First, I'd like to briefly introduce myself. I joined Line Plus in 2016. Up until now, I have been working on training AI models, having gone through mobile app, on-device ML, and federated learning. What I am doing recently is what is on that very last line. We teach AI what it can and cannot say. This is topic control. To briefly summarize the characteristics of topic control, they can be summarized into these 4 points. First, it clearly defines the boundaries of operations. Next, we block topics like political propaganda. And, as Jongwoo mentioned earlier, it's an external checkpoint that's controlled at the front end, not the system itself. Finally, it operates independently as a standalone product, regardless of the main model. So in short, you can think of it as a kind of bouncer that guards the front before reaching the internal system. I would like to discuss the challenges we faced when actually creating topic control. I mentioned that topic control sets a kind of operational boundary, right? But the problem is that this boundary varies for every service. For example, if you ask, "Should I buy this stock?" to a banking consultant. However, if you look at banks, there are usually robo-advisors for investments, right? If you were to use that, this would probably be on topic. As another example, if you consider the agents included in Thematic or PayPay, you can probably easily imagine that this scope cannot be covered. So, if the number of services that need to be supported increases, what should we do with Guardrail? Should we train them all separately? If we had to train separately each time the number of services is increased, it would not be realistic. So the method we chose is dynamic conditioning. As you can see, each service already has. We have system prompts that describe the service purpose for our agents. We then abstract this into a kind of system definition and feed it into the topic control system along with the user's message. The topic control model then receives the input. Based on the service definition, it determines whether the received message falls within the scope of the service. This means that we can cover multiple services with just one model, and even if a new service comes in, we can immediately expand to it. However, this presents yet another new problem. We mentioned earlier that we use system prompts as input, correct? However, the problem is that this system prompt was not created for the purpose of a guardrail, so it's usually written for agents. So what needs to be blocked? Most of the time, the instructions are very vague. For example, things like, "Do not mention politics," or light greetings that should routinely pass, or natural small talk, for example. Because the scope of such things is usually broad, they are not written in detail, so you might get blocked by a guardrail. In other words, a guardrail needs to explicitly know, a guardrail perhaps. It means that all the things that need to be passed are missing. Furthermore, if the number of services increases, it is almost impossible for people to manually add them one by one. So the second solution we devised to solve this problem is called self-evolving guardrail. As you can see in the slide, instead of humans improving the system prompt, we have agents form a team, and then they provide feedback to each other. We can assign different personas to these agents, as is commonly done, or we can have them follow a base model without any persona. For example, by forming a team with GPT, Gemini, and Claude. However, the key here isn't just improving the prompt, but using the benchmark dataset that's included as a kind of loss function. So, it's an approach where the agents optimize themselves. Therefore, each time the loop runs, it continuously optimizes based on the previous results. So let me show you an example of how performance improves when using such an agent team. We conducted an experiment with this on a customer service agent for a delivery service. Then, we formed an agent team using GPT and Claude. So we used about 900 cases of Japanese, Korean, and Thai. By keeping the model as is and only evolving the system prompt incrementally, we found that compared to the original, the accuracy improved to 73%. When performing this task, additional model training, or you can see that there's about a 9% performance increase just by improving the prompt. The important thing here is that if you look at it, V1's performance is slightly lower than the original. When we simply added a very abstract instruction like stay within the service scope, the performance actually dropped like this. So when we replace these with concrete examples in the second and then the third versions, you can see that the performance actually increased dramatically. So to summarize, when we added specific examples, there was a significant performance improvement. And if we were to apply this to various services, we gained insight that agent-based automation is essential to apply various services. I have spoken about topic control so far. I will now hand over to Sua for the next presentation. Thank you. Hello. I am Sua Lee from the Line Plus Applied ML debut team. Now, among the external AI guardrails, I will explain further on. I will now explain hallucination detection. If the topic control you saw earlier was a doorman preventing questions from entering, If they were outside the service scope, hallucination detection is a fact checker at the exit confirming the truthfulness of answers. I'd like to greet you all once again. I joined Line Plus in 2025 and am currently interested in technologies that ensure the safe operation of generative AI in actual services. Today, I will talk about how LLMs generate. I will now talk about the hallucination detection guardrail, which verifies whether the response is supported by actual reference documents. First, let's define what hallucination detection guardrail is. You can think of it as having 4 attributes. The first is a grounding check, that the generated answer is supported by the retrieved factual document. The second is risk coverage. It covers various types of violations, not just simple factual errors, but also character confusion, false premises, and violations of complicity policies. The third is the external check. Since a separate model verifies the answer after the main LLM provides it, the core model is not modified. The last is lightweight verification, comparing 2 sentences without calling another large LLM to see if the evidence supports the answer. It runs a small NLI model locally. Here, NLI, an abbreviation for natural language inference, refers to 2 sentences. You can think of it as a small fact-checking model that verifies whether the supporting document substantiates the answer. Since there are no external calls, we can reduce the risk of data exposure together. There are 2 main pipelines. First, there is the evidence search phase, which is the retrieval of evidence documents. We find documents through 2 methods: keyword search and semantic search, and at this stage, reliable. If it cannot, instead of passing or blocking, it is passed on as an unsure judgment. Next is the fact-checking model stage. We compare the source document and the answer to determine if it is difficult to judge whether they are supported or if they conflict. And if there is a clear conflict, we categorize it as a fail. From a structural perspective, I'd like to emphasize that we didn't add a new large-scale system, but rather simply added a light search verification step on top of the existing Chroma document storage. There is no separate search server, nor a second LLM call. As we started to build guardrails, the first problem we encountered was that the retrieved document was not immediately usable for verification. 3 patterns were repeated. First, gap is. Can I get a refund? The correct document for "is a refund possible" is phrased as refund of payment possible upon return, so it cannot be found with a keyword search alone. The second is a negation trap. Does this plan include international roaming? Is it included? The correct answer is a negative document, but meaning-based search treats negative and positive almost the same. The third is identifier collision. ORTA 23 and A32 are almost identical in embedding, but in reality, they are completely different identifiers. Ultimately, hybrid retrieval was necessary because retriever relevance and verification quality are different axes. The first solution divides the retrieval stage into 2 perspectives. Keyword search is strong in cases where a 1-character difference is crucial, such as ID, version name, or negative expressions, and meaning-based search can capture documents with similar meanings, even if the expressions are different, such as foods I dislike and I can't eat cilantro well. The important point is that we did not attach a new search server. We retrieved a list of documents from the Chroma we were already using and built a lightweight keyword index in memory. The 2 results were combined using hybrid retrieval. Keyword search is not the main player, but a supporting signal that boosts ranking only when accurate words are crucial. The table on the right shows our trial and error. In all our cases, the performance of combining standard methods, retaining only the intersection, and a 50-50 weighting being decreased. In conclusion, rather than adding complex systems, a better approach is to center semantic search and use keyword signals as a small auxiliary. That it was correct. The second solution was to cut the source document into smaller pieces and insert them. The left and right sides of the slide contain the same facts. On the left, there's just one sentence containing facts, while on the right, the same sentence is mixed in with several paragraphs. The results were completely different. Short sentences were passed, while long pages, even if they contained the same text, were still pages. The reason is that a fact-checking model, unlike a human who scans documents and reads only one sentence, compares the entire input at once. If the basis is short and focused, judgment becomes relatively easy, but if irrelevant content is mixed in, the signal weakens. Therefore, we divide documents into sentences, not paragraphs, and convert tabular data into natural sentences. I have added section headers for context. However, there were also side effects, similar sentences, or if sentences with different dates or subjects are retrieved together, it could send a false positive signal. We have implemented a safeguard to switch to fail only when the conflict signal is sufficiently stronger than the supporting signal. I will summarize the results. Initially, we only used meaning-based retrieval, but for Japanese cases, 4 out of 5 were at a 0 level, and for English cases, 5 out of 8 were at a 0 level. Failsafe for conflicting evidence at the sentence level. In Korean, it got 9 out of 9 correct. The important point is that it's not that things got better by adding more complex systems. This is the result of better finding evidence for verification, organizing it into a readable format for the fact-checking model, and removing unnecessary steps. Operationally, we do not call the large LLM again. Because a small fact-checking model verifies it, we can reduce external call costs and the risk of sensitive information exposure. The conclusion of this section is twofold. First, instead of calling the large LLM again, a small local fact-checker was able to perform sufficiently valid verification. Second, the pattern of first finding evidence and then verifying the answer is not limited to hallucination detection. It can also be applied to other external guardrails. Finally, to summarize, guardrails are a key layer for enhancing security in the AI era. Today, we have shown you 5 types of guardrails. Text moderation filters harmful content before it reaches the user. Prompt injection. Detection preemptively detects attacks that attempt to overwrite system prompts. PII. Filter masks personally identifiable information before it reaches the external LLM, and topic control is like a doorman at the entrance, keeping the AI agent within its own topic. Hallucination detection serves as an exit fact checker, cross-referencing LLM responses with source documents. As shown in the table, all 5 types have high accuracy and fast response times, making them suitable for deployment in an operational environment. We hope you find them useful for enhancing the security of your services. If you have any questions, please ask the speaker or visit our booth. Thank you. Hello, this is Jungsu An and Chi-Hoon Lee from Line Plus AI Hub Dev Team. Today, we would like to share the problems we encountered while operating the agent harness and how we complemented them. I will first explain the common picture for using harness in the first part. Rather than delve into the detailed implementation our team uses, will be discussed later to understand the basic perspective for hearing the detailed implementation. Please consider this as an overview of the concept. Next, Chi-Hoon will speak. Our team. In fact, I will explain in detail the structure in which harness was applied. Let me briefly introduce ourselves. We are developing systems and platforms that apply AI technology to actual services and internal work environments. Currently, there is a project called AI Friends at the top of the line app chat room and operating. In today's presentation, I will introduce what kind of problems our team is solving with AI. First, to very briefly explain harness, we will view this as a structured work path where the agent performs its tasks. If you ask the model to fix the failing tests, then which file you should look at first, what tests should be run, it is all ambiguous as to when we can say it is complete. Therefore, the model makes a reasonable guess, but the speculation does not always align with our team's standards. The harness is, to reduce this ambiguity, to combine document tool verification criteria, records, and so on. It plays a role in creating a path that agents can follow. In this slide, it's not just the model itself, that the environment in which the model operates is important. I will just briefly touch upon this point. According to the definition in LangChain, we propose to view an agent as a model plus harness. This means that everything except the model should be seen as a harness. The model performs reasoning, generation, and selection. However, for actual work to run stably around the stage, give information, connecting tools to create a workflow, and verify, we need an environment that prevents risks. So, I'm going to call this surrounding environment a harness. Last year, we viewed the agent as the central component. There is a model, and there is a runtime where the model runs, and there is a context and tools to refer to. In other words, an agent could be described as model plus runtime plus context plus tool. The coding agents we are discussing this year are one step further, moved forward, including the order of operations, when to stop, what to verify, and how to prevent risky actions, while enhancing the environment around the model. We call this environment harness. We have started calling the work of enhancing this environment harness engineering. The important thing is that the harness, not some hidden ability inside everyone, but rather it refers to the working environment created around the model. What does it mean to pave the way? It does not mean hard-coding the order of actions on the stage. What about models? We still make that judgment. However, which document to look at first? Which procedure should repetitive tasks follow? What tools can be used? You will be given an environment such as how to check the results. If you ask Q, rather than creating a single, fixed route, it is closer to creating a road network with collection points and lane guides. Just get a feel for it. Specifically, how each gate operates. We will look into this in more detail later. the actual harness is, rather than a single massive device. It is created by gathering several small components. For example, instructions that tell you what documents to look at, a procedure that guides repetitive tasks, the tool that actually performs the action, checking the results, and there is a record of the progress. Here, just note that these materials exist. Lee. In the latter part, these constraining elements, let's look in more detail at how they are integrated into operations. The model ultimately selects the skill. However, choices are not made completely in a vacuum. Depending on what skills are visible, how clear the explanation is, what context is provided, and what feedback is given when something fails. Follow? The quality of everyone's choices changes. So harness? It's not about making judgments instead of the model. It is closer to creating a working environment where better judgments are more likely to be made. Good judgment does not come from within the model alone. It is also part of good judgment to see what choices look like. Until just now, we looked at what skills the model chose. Here, I will briefly define the term skill. I would say it is a procedural task that repeatedly performs skills. For example, how to fix a test, API specification, such as how to analyze failures, or how to write release notes. It can become a single skill. The model sees the request. It selects the most appropriate skill among several skill candidates. However, another question arises here. Will we create this skill and working environment anew for each project? Or whether the team will create it in a reusable form? We are solving this problem with the concept of a plugin. The plugin this is an official term that exists in both OpenAI Codex and Cloud Code. Of course, the implementation of the two products is slightly different. The Cloud Code plugin is Skill Agent Book. It's closer to an extension package, including MCP. The Codex plugin it is closer to a unit that deploys skill integration MCP in the form of a reusable workflow. So here, rather than focusing on implementation differences of specific products, I will focus on common concepts. We will consider a plugin as a packaged unit that allows teams to install and share the harness they created. For example, let's consider the task of modifying a polling test. You can define separately what logs to view, what tests to run, and what to consider a pass for each project. However, if we do that, the working methods and verification standards differ for each project. Therefore, we have adopted a skill and path-based verification procedure, such as fixed following tests. We bundle the necessary tools and context together to create a plugin. Then, even if the projects are different, the same work procedures, you can reuse the same verification criteria. In other words, the plugin it can be seen as a unit that shares the work methods verified by the team, rather than simply adding features. A good harness requires three main things. Firstly, we need to have predefined criteria for what constitutes a pass. Secondly, we should not just trust what the model says it has completed, but there should be a separate verification process to confirm it. Third, with the next task, so that it can continue. The progress and basis of judgment must be recorded. These three things are necessary for the agent to, going beyond merely generating answers. You can work repeatedly using the same criteria. A harness is not a structure that provides a single answer and then ends, but rather is closer to a loop. The agent acts, confirms the results, records the content, and these records then influence the next action. The significant change is not whether the model said it was finished, but rather, this means that the standard changes to whether there is remaining evidence that can be interpreted in that way. This is the general overview I wanted to present. Now, Mr. Shiwu will explain our team's advanced harness. So far, we have looked at the common foundation that allows agents to survive long tasks. From here, we will look at the gaps in common harness setups that our team actually encountered. What kind of things would there be? First, there's static skip fold. The harness engineering that is often referred to these days assumes a static environment. The goal is to handle all task types with a single harness. It becomes awkward if the prototype and the operational code pass the same verification. Second is the soft gate. When we provide the agent with, instead of prohibiting an action, it might display a warning and proceed method. It's over when a person says, "I understand," and moves on. Third, there is the drift between spec and code. Requirements or specs change, and refactoring is frequently done. Static spec documents can be problematic. As PRs are merged, the specifications increasingly become inaccurate. Fourthly, the lack of self-evolution. When the specs are wrong, we write them from scratch every time. This is because we don't know the history of what has been implemented and changed. We have addressed the 4 gaps we saw earlier with 5 layers. Due to that flag. Briefly, if I may speak about the design principles, from the inside out, the inner part is human. It is a gradation of degrees of freedom and enforcement that machines compel as we move outward. We will look at the 5 layers one by one, and then delve into them slide by slide from the next slide. First, it is a spec harness contract, before coding. Human and the agent. This is where we meticulously document the company's standards. Secondly, it is a multi-agent review, each with a different model and a different perspective. The sub-agent checks the same changes against different criteria. Third, within the runtime harness. A sandboxed runtime harness that is dynamically generated during the operation. This is a form where customized harnesses collectively cover various requirements. Fourth, we have a hard gate. We actively use hooks to prevent the model from passing through the gate in advance. We enforced these rules so that they could not be ignored. Lastly, the 5th point is self-evolution. We have strived to automate the process of fixing the spec when it fails due to requirement changes, refactoring, etc. What we'll look at in Layer 1 is the order. Instead of writing code first and then setting the acceptance criteria, it's a way of accurately telling you what the path is. If we agree on the passing score first, the human data reviewer will then, they look at the same criteria. The file containing the contract is manifest, and the spec manifest run.setch file leads to the actual execution. The spec. If we define what a pass is, you can think of manifest as a map that connects which harness lane runs, which run shell file for verification. At level 2, we provide various models with the ability to utilize them. The same changes. Claude 3 types of sub-agents. The CoderX review agents can currently observe multiple items. The reason we use 2 models together is because their blind spots are different. Our team made this decision because we found that while token costs are high, the cost of missing bugs is much greater. Let's learn more about the runtime harness we will examine in Layer 3. The runtime harness. This refers to sandbox verification attached to specs and code, which the agent directly runs while working. You can think of it as a dynamically generated agent verification environment. If you ask what's different from existing CIs, it's not a CI that runs and ends, it grows during the task. Not someone else running it for you. The agent creates and operates it on its own. It becomes impossible to simply write code and not run validation. The reason it's runtime is because we need to verify things that can only be known by running them. This is validation that we encountered while refactoring actual service integration, parts that diverge as requirements change. This is because we cannot statically cover all of these things in advance. Therefore, we added another runtime harness layer on top of the static gate. This is a method where two automatic checks are attached before and after each time the agent executes a command. You can think of it as the system handling everything on its own, without human intervention. The hook attached before is a gatekeeper. The command is checked first before it is actually executed. Has the review and verification been passed? If not, it will be blocked on the spot. For example, if you try to modify or generate code without a design document, the commands simply won't work. Secondly, this is the record sheet. When a command ends, the result is written on a line, and the latest status is continuously updated for the next check. The key is that these two run regardless of the model's judgment. Even if the model judges, let's just skip this one, without any input from a human, because it was enforced with a hook, it will always be caught. Up until now, if the picture was of an agent passing tests laid out by humans, in this runtime harness, if the agent needs a validation harness during its work, it creates it directly. There are 5 steps in the process displayed on the screen. First, we examine how various harness lanes are structured, then assemble them and run them on site. The key here is that it doesn't end with adding validation. The next step only proceeds if the added validation passes. If it's a red light, the commit itself won't happen. So, the agent becomes both the subject being inspected and the subject doing the inspecting. In Layer 4, we discussed how the harness lane can be efficiently managed. First, line detection. You can think of each of these as a unit of validation. You can think of one type of verification as a lane. Each time, a lane turns. The result is indexed by checks. It accumulates automatically line by line in a file. When? Which branch? Was it successful? How much time did it take? Those things. It is a method of recording it as a file. When needed, these accumulated history ledgers are examined using a tool. Audit Trend looks at the flow and whether the same lane gradually slows down or frequently breaks. And the Parallel to Write tool helps us assess the cost-effectiveness of our harness engineering. It shows us whether this harness engineering is effective in verification or just consuming time. This kind of verification, we separately installed tools. The key is that we don't collect the results separately, but instead record them in file form and append them so that the agent can easily refer to them at any time. I will now explain the hard gates in Layer 4. This isn't actually a warning, it's a blocking mechanism. Agent is. At the moment, it attempts to take dangerous actions, regardless of the developer's intentions. This method completely blocks the tool call itself. So, what about coding agents? It will enter its own loop, but ultimately, it will be considered a failure, and then it will seek other paths or request feedback from the user. There are several points that block it. If a review or validation fails during a commit, it is blocked. Even when pushing, if there is no design document, we block it. And when we submit a PR, we need to consider whether the harness lane I mentioned earlier has passed, and if the verification during command execution will be reliable or not. It is a system that determines and blocks such things. These hard gates. It can run on developers' local PCs. You might think, can't I just turn off the hook on my PC? However, it only operates in one's personal environment. Already, Once the developer and agent have reached an agreement after commit, push, and PR, those harness engineering are meant to be a common standard for the team and are designed to always work. Our team tried to take it a step further by creating a plugin. If layers 1 through 4 were about adhering to human-made designs, this is about what to do when the design itself is flawed. Usually, people rewrite or modify it from scratch, but this layer is an attempt to automate the process itself. I would like to highlight 2 stages in the overall flow where we put in particular effort. The first is wonder. When something needed to be fixed during evaluation, we didn't start by making a modification. Where was the spec empty that caused it to fail? What we don't know. It is a method of conducting deep interviews with user developers. This is the stage where we accurately define the problem and, afterwards, Reflect creates a revision to learn from the empty spaces. Secondly, there is equate. The proposed changes are not automatically reflected and must go through human approval once. We added 2 more things here. If a change is rejected once, it is automatically excluded from the next candidate list. We do not repeat the same proposals. Secondly, if there is no response for 30 minutes to an hour, it automatically stops, and unapproved changes are. It's a way of not being neglected. What is the core of the pipeline for automatically evolving skills? This means that it is not automatically reflected, but rather requires at least one human approval. Automation does not exclude people. The key is to make human decisions easier and to allow people to focus on those decisions and create this skill. As we created the self-evolving pipeline, another thing was added. As Jung-Soo explained earlier, a skill is a kind of work instruction that tells the agent how to perform a task. Has been explained. As a result of our operations, we confirmed that this manual, which we call a scale, changes more frequently than the specifications. Therefore, we designed and implemented the manual self-skill to be continuously improved. This improvement method borrowed 3 concepts from model training. First, I'd like to address the go. We iterate through multiple generations instead of completing the revision in one go. And it is a method that gradually reduces the number of candidates created in each generation. In the first generation, we broadly attempt up to 10 options, then reduce the number as generations narrow, leaving only 1 at the end. In the beginning, we broadly explore, and in the latter half, we focus on the most promising one. It is a method of narrowing down the direction. Secondly, this is a unit of work that reflects optimized skills immediately. If we compare it to a coding agent, we gather and reflect on the feedback at the end of each session. This is because these accumulated changes can be adopted stably. It allows for managing versions of changed manuals and skills, enabling later tracking of why these changes were made. The most important point is that all of these things are applied in the process where the agent coordinates and asks people. While creating skills, we made it so that specifications and skills can be modified together. It was a method of consolidating approvals into a single bundle rather than receiving them individually. This is because skills and specifications are a pair. A specification dictates how code should be implemented and how functions should operate. What about specs and skills? They have become inextricably linked. And what about specs and skills? This is because if one side is misaligned, the next generation will end up misaligned as well. So we'll write down the 2 revisions to a temporary folder. Lastly, by renaming the folder. Either both are applied or neither are. We did it this way. The flow we have seen so far is developers. If we were to do each one in detail, there were many steps involved. Therefore, we have introduced the same goal to this plugin. Unlike the goals of Claude Code or Codex, which were based on existing models, this goal is literally to create a valid goal for runtime harness and verification, and internally use it as a standard for the codebase. This is a method where actions are performed based on a set goal. However, this goal does not mean that the agent can simply rush ahead and code whatever it wants. If it gets stuck, it still stops. And because the standard for humans is clearly specified, even if we set it as a goal, we actively use clear criteria for people and the Ask User Question tool. If you modify a large code base all at once, it may not end in one session. Context and windows are found, and people also get tired. Complex features are. Code review can prevent you from cutting it into smaller units. The problem is that when the session changes, the memory of what the previous session did is lost. So, what happened as we moved towards the final stage was that we enabled logging in and effectively viewing logs. The key is that the agent automatically logs the "I've completed this much" handover document every time. This slide summarizes how we addressed the 4 issues raised earlier with the layers we created. To briefly touch upon this, the problem of design being prematurely finalized is addressed by the spec harness contract. We've made it so that they receive it. Secondly, the issue where the inspection only warns and doesn't block is, as I mentioned, the runtime harness and hardgate work together to block access completely. When the session changed, the problem of losing context was addressed by applying session continuity logs. Fourth, we proceeded with the self-improve pipeline for problems that the design itself could not fix. All of this is local to the harness and manifest, starting with a saved file, Cloud Code, or Codex. No matter what it is used for, it is designed to operate correctly. When you fix code, you have spec code validation. These 3, they start to work somewhat independently. Over time, there are many cases where the specification is written one way, but the code is completely different. This is the moment when commonly known documents become false. If we adopt this harness plugin, the specification and the code remain synchronized, so ultimately, the specification is the code. It becomes possible to maintain a certain motivation. This slide compares the same change using 2 different paths. Number 1 is a method where you write the code first and then add verification as you go. The problem is only discovered after it has been merged. What about after? By placing the spec and harness first. It must pass the validation criteria. This is how it proceeds correctly. If we summarize this plugin into 4 messages, first, a warning is not a blockage. You must deny the tool call when you truly intend to block it. Harness comes before code. Rather than writing code and then adding validation, we must create the validation first, and the code must pass that validation. The specifications also become part of the agent's learning when the spec is incorrect. Instead of people rewriting it, they create patch candidates. It is applied with human approval. What if we use multiple models together? They become mutually secure. If Claude and Codex read the same contract, it would reduce the model's blind spots. So far, we have discussed the plugin for the harness developed by our team. There is still a lot of work for our team to do. Setting up metrics to quantitatively check how the harness has improved. The method of aligning the specifications of planning documents and development documents. Examples include various research and experiments for more efficient token usage and subagent settings. Our team is continuously considering how to teach human standards to agents and harnesses. Thank you for listening to our team's concerns about creating a stable and scalable codebase rather than a rapid development cycle. Thank you for your cooperation. This session will be about we have streamlined our QA operations with AI agents. It's not just that. I will mainly be talking about how to establish AI utilization throughout the entire organization. This is the flow of today's presentation. First, I'd like to briefly introduce our organization and our QA operations. Next, QA agent platform. We call it QAAP, and after introducing what QAAP is, I will talk about the mechanisms and initiatives we undertook to overcome two challenges we encountered when establishing AI utilization across the entire organization. My name is Guida from the Product QA unit. We are a QA specialized organization belonging to the cross-sectional organization of the CTO domain. Our organization has about 20 members, with offices in Fukuoka and Tokyo. We provide long-term and short-term support for various projects, contributing to the service quality of line and FUE. Often, is Q&A referred to as Q&A? I'm often asked about this. This stands for quality assurance. What do you mean by quality? The attractive quality when users use the service? Not only the quality of the service itself during use, but also and are involved in the quality of the development process. Therefore, our role is not just to check for defects as a gatekeeper before release. Such extensive quality assurance. In order to accelerate efficiency even further, we developed QAAP of QAAP. Let me give you a simple overview. QAAP is an organizational repository-based template platform that runs on Codex CLI and Codex App. It is managed by GHE and can be utilized by anyone. The setup process is also well developed, and parts that might cause issues are automatically configured with shell scripts. When a user requests a task from Codex, it connects to various MCPs within the company to gather information based on that request. Once the information gathering is complete, we use specialized skills for each QA task, which have been infused with QA expertise to create test deliverables. At every point in this workflow, we also have a robust multi-layered defense system that monitors and blocks inputs that could lead to security risks. Additionally, it includes custom skill support features tailored for specific projects, as well as it also has enhanced management functions, such as a custom skills market. QAAP2? What kind of effects have we seen since the entire organization started using it? The work time for corporate sales was streamlined by nearly 50%. The number of QA deliverables generated increased by about 1.5 times. The AI replacement rate for deliverables also reached close to 70%. Like this. As productivity improved. For example, people can focus on tasks that require human intervention. Additionally, we are now able to secure time to think about AI utilization. That concludes our presentation, an introduction to the organization, and a brief introduction to QAAP. Now, I'd like to hand it over to Fukunaga-san, the development lead for QAAP. My name is Fukunaga from the Product QA unit. From here, I will talk about the challenges we faced and how we dealt with them as we promoted AI utilization across the entire QA organization. Today, I will focus on two themes that are likely to occur in many organizations. The first hurdle is the challenge of pressing the accelerator and the brake at the same time. This is because, as an organization, everyone wants to use AI more to accelerate their work and achieve results. This is an accelerator we want to really push. On the other hand, there are risks regarding safety that we need to be careful about. We want to make sure the brakes are working properly. These two seemingly contradictory things. At the same time, it needs to be established across the entire organization. This is the first theme. The second hurdle is to expand AI utilization to the entire organization, not just a few individuals. So-called early adopters will proactively master its use. This in itself is a very good thing. However, that know-how tends to become tacit knowledge. This is something skilled people deliberately hide. That is not the case. Rather, there are more people who actively share their methods. However, for others to replicate it in the same way it's difficult due to various factors. Many organizations may have similar concerns. To address these challenges, we have been working on both the system and the initiatives. From here, we will introduce the specific contents. Well then, first, I will speak from the perspective of the mechanism. I will talk about a case study where we address challenges through the underlying QAAP. First, the first hurdle, regarding the accelerator and the brake. Regarding the accelerator side of the story, as I introduced at the beginning, we have confirmed a certain level of effectiveness, primarily through the use of preset skills that cover a wide range of QA tasks. However, since that topic is individually optimized, we hope to introduce it on another occasion. Conversely, the brakes are directly related to the main theme. This time, we will delve into that in particular. First, regarding the brakes. First, as a premise. In the environment surrounding AI, there are risks that cannot be ignored. As you all know, in 100 years, something like Mainichi will emerge. For example, handling confidential information, prompt injection, and preparing for supply chain attacks. Originally, I would like to continue to push the accelerator for AI utilization for direct work efficiency. Well, these kinds of problems come up every time, and we end up having to slam on the brakes and play catch-up every time. And as an organization, we need to ensure that each individual is able to handle that. Are we understanding the risks and using it appropriately? It is actually difficult to accurately grasp the actual situation of each individual. In other words, entrusting such measures solely to individual vigilance is not a realistic way to ensure organizational security. Therefore, we developed QAAP, a platform that incorporates guardrails against such risks in advance. We operate by forking this for each user and team, making it a home base when using AI agents. By doing so, the maintenance and updating of guardrails, such as risk countermeasures, the original upstream is centrally managed, and each individual simply syncs, creating a system where countermeasures are uniformly applied across the entire organization. Next, I will briefly introduce the contents of those guardrails. The underlying concept is what is known as multi-layered defense. We have multiple layers of countermeasures in place, so even if one is bypassed, the next layer will stop it. We are creating such a state. This time, I will briefly introduce some typical examples. For example, we will introduce guardrails for familiar secrets that are often handled in practical work, such as API keys and tokens. For example, if you store a personal access token in plain text in an ENB file, there's a higher risk of it leaking externally if the device or repository is ever compromised. In QAAP, such information is managed using encrypted storage, like 1Password and Keychain. We have a policy of retrieving secrets safely only when needed. This policy is automatically enforced by the QAAP as a system, without relying on the user's discretion. Here are examples of our multi-layered defense. First, secrets cannot be read directly from the MV or environment variables, and it is blocked by Codex's execution policy. In addition, we conduct checks before and after that. At the entry point before that, when the user sends a prompt to the AI, when a string matching a common pattern, such as an API key or various tokens, is detected, transmission is halted just before the data is passed to the AI. And even if it slips through the entrance, the output side is checked once more. Before creating a request, this checks if the code or skills created depend on or refer to secret files from a different angle than the initial entry point. By layering these guardrails at multiple points, we are able to handle various cases. Furthermore, it not only stops risks without the user even being aware of it. At the same time, we encourage the individual to become aware of the issues, alerting immediately when it's caught. It tells you why you were blocked and how to deal with it, with guidance to the relevant documentation. Indeed, from the users themselves, we received feedback that this notification helped people understand the necessity of risk countermeasures and how to deal with them. While automatically mitigating risks, user understanding also progresses. We are seeing some positive results in that regard. I'd like to briefly touch on a few other points. First, there is the risk of introducing dangerous elements from outside, such as the supply chain attacks mentioned earlier. This involves using only secure internal registries and NPM settings. During installation, we've configured it to not run scripts automatically. Another is the operational risk unique to AI agents. For example, file deletion, such as RM, preventing the execution of an irreversible deletion command. We control it to limit operations to reversible ones, such as moving to the trash. With this, we are prepared for the worst-case scenario where AI might mistakenly delete everything, making it irreversible. So this is just a part of it, but we have put in place guardrails in various places to avoid risks as much as possible through mechanisms. That was a brief introduction. However, for those who are already familiar, this content might have seemed obvious. Despite this, why are we making such detailed settings? Yes, various guardrails include: there is a common purpose. What is it? As described in the slide, this means we are prepared for the characteristics we are not good at. All right, let's take a look at these one by one. The first characteristic we're not good at is as instructed. The second is, let's remember important rules. The third is reading and correctly understanding the written text. Fourth, saying, I don't know, when you don't know. Yeah. And finally, the agent autonomously gathers missing information. These all seem like things that should be self-evident. Therefore, I truly feel every day that I am not good at these things. This is not about AI. This is about humans. This applies very much to me as well. Everyone, are there any questions? They might think, I don't need to say it. You'll understand. Just because it's written doesn't mean people will read it. If you don't understand, I assume it will investigate and ask around. That expectation, the experience of completely missing each other, and the more we took things for granted, the more this can lead to fatal misunderstandings. So finally, to summarize this part, at this point, some of you may have thought this. That's right, the changes on the AI side are indeed very fast. That is why QAAP is. We focused on what wouldn't change. That is, this is about the weaknesses of humans who use AI. Therefore, instead of relying on human attention, we stop it with a mechanism. This is QAAP's consistent approach. This is our design philosophy, and what I most wanted to convey in this part today. Now that I've said what I wanted to say, the first hurdle, balancing the accelerator and the brake, is concluded here. To summarize, equipped with both accelerator and brake as standard, users can focus on the accelerator. That was the story of how we solved this through role sharing. However, just providing the mechanism is not enough to ensure everyone utilizes it. That is the second remaining hurdle. How do we break through this and move forward? Now I'll hand it back to Ueda-san to continue the story. I'm back. The second hurdle is not. I will be talking about spreading AI utilization throughout the entire organization, not just to a select few. Earlier, Mr. Fukunaga talked about the QAAP. This is really important. Having just a mechanism makes it difficult to embed it across the entire organization. To embed the system within the organization, it's crucial to have specific mechanisms in place. Regarding this initiative, I will now elaborate. So, to get to the bottom of it, we simply iterated through these three elements: understanding the current situation, devising countermeasures, improving, and measuring. If we measure again, we can see the current situation and then improve. Exactly. It's not a special framework or anything, it's just a simple improvement loop. It seems easy, but actually, it's quite difficult to keep it running smoothly. Let's take a look at each of them. So, first, regarding understanding the current situation, approximately 1 year before developing QA app, the organization was already promoting the use of generative AI. There are two main points: setting up a shared space and initiatives across the entire organization. For example, in a shared space, we created a chat channel on Slack specifically for AI-related discussion, or enabling casual communication. We created several subcommittees focusing on AI-related themes. Over a period of 3 months, we had them do various things, and we also held LD meetings. As for the efforts of the entire organization, at the monthly unit-wide meeting, we share the organization's overall policy on generative AI, information on trends, and also we felt we had done everything we could, such as including AI items in goal setting early on and providing individual follow-ups in one-on-ones. So, we created the platform, actively shared information, and provided individual support. But, however, the subsequent actions are left up to individuals, and ultimately, each person has to make an effort on their own. It was. From the perspective of those promoting AI utilization, we feel like we're doing a lot, but there's a weak sense that the organization as a whole is raising its level. And I had the feeling that there was a variation in the degree of utilization. To be honest, I don't know how each individual is using it. Therefore, I decided to accurately assess our current position and visualize the organization's utilization of AI. Therefore, we created something called the AI Skill Maturity Model. This is, we use Dene's AI skill evaluation metrics as a reference and customized them for our office. For example, levels 1 and 2 involve using chat AI for organizing thoughts or summarizing text, which are supplementary uses not integrated into business processes. On the other hand, levels 3 and 4 utilize context engineering and harness engineering, among others, we are currently in a state where we can handle deliverables and business processes with AI leadership. We use this maturity model to conduct a survey on the extent of AI utilization. Looking at the actual survey results, more than half were at level 1 or 2. On the other hand, there were already people who had reached levels 3 and 4 and were able to perform their work with AI-driven operations. The data clearly showed us that there was a variation in the degree of utilization. Of course, we want those who are good at it to keep advancing. From an organizational perspective, we want to return that to the entire organization and hope it raises the overall level. Unless we stop individual efforts of working hard and move forward as an organization. Therefore, by creating a system, we make the knowledge and know-how of those who are ahead available to everyone. I believe we were able to make these decisions because we could understand the current state of the organization through data. We have the data, so the next step is to take action. So what we did first was to hold a full-day offline hands-on workshop to get the entire organization to use QAAP. Based in Tokyo, but we also had people living in Nagoya. We gathered everyone in Fukuoka and adjusted the operations of multiple projects as much as possible. This was in February 2026, and at that time, the entire company was still primarily online, but we intentionally brought everyone together to conduct it offline. So why did we specifically go offline? Ultimately, each person doing their best resulted in a structure where individuals had to bear the burden of the mechanisms themselves. The fact that we're not getting consultations doesn't mean they're self-sufficient. It means they don't know enough to ask. It's hard to share knowledge, and I can't ask deep questions, so it's difficult to apply it to my own work the next day. Ultimately, and only those who could do it would. As an organization, that's not healthy. This encompasses all such thing to resolve. At the same time, in the same place. Let's do it together, right before your eyes. By doing so, if you don't understand, you can ask right there, how do I do this? We designed the hands-on training to be applicable to their own work, so they could use it in their work starting the next day. Then, those who can do it from the start will support those who are not yet able to, on the same PC. You absolutely cannot create this kind of atmosphere online. Although cost and adjustments are challenging, we decided that creating an opportunity for everyone to at least experience it was the most important thing at this phase, and so we went ahead with it. Because we conducted hands-on sessions, everything started to run smoothly. That's not how it works. Hands-on sessions merely create an opportunity for everyone to start on the same footing. If we end there, we'll revert to everyone working on their own again. We need a mechanism to continuously cycle through improvement loops to ensure adoption. Therefore, we decided to visualize the current situation again. At that time, the maturity model that I introduced earlier had served its purpose. So we switched to a QA app usage questionnaire. Based on that survey data, we held 3 improvement sessions. The first is, all members also participate in the QA app regular meeting at various events. This includes policies related to AI, information sharing, and updates for QAAP. Based on a survey filled out by our members, we set aside time for them to discuss amongst themselves. The second one, in the regular meeting of the QA app promotion team, we incorporate opinions and improvement suggestions from surveys into the QA app platform's enhancements. For example, the output accuracy of this skill is low, or I want a skill like this, and so on. The third is at the leader's regular meeting. By observing the trends in the questionnaire, we will formulate a strategy for how to provide individual member support. If there's a member who isn't making progress in utilizing it, identify the obstacles and address them. One questionnaire simultaneously drives 3 improvements: horizontal deployment, platform improvement, and individual follow-up. You might have a question at this point. You were already doing information sharing, regular meetings, and outreach, right? So why did things suddenly start moving once everyone could use QA app? This is because the resolution of sharing changed due to the existence of the QA app mechanism. Because everyone is on the same common system, QAAP, you can have common, concrete discussions, and it becomes easier to reproduce others' clever ideas yourself. Within the loop of initiatives we've been carrying out, specificity, and reproducibility emerge. I think this is the What happened as a result of continuing these steady improvement loops? What does that mean? Recently, it has become possible to visualize the utilization status of generative AI within the company on an organizational unit basis. The horizontal axis represents the AI utilization rate. The further to the right you go, the more people in the organization are using it. The vertical axis represents the median number of uses for everyone. The higher up, the more frequently it is used. In other words, the further you go to the upper right, the more people are using it extensively. Now, where are we? It's the top right one. Usage is 100%. The median frequency of use as well. All unit leaders and all members are proficient in using AI agents. Of course, it wasn't like this from the beginning. As a result of continuously iterating through persistent improvement loops, we have arrived at this point. Of course. Not only has it become a state where everyone can use it as a matter of course, but as introduced at the beginning, it has also clearly shown results. Here, let me introduce one report. Google's Dora, known for its 4 keys, I believe. This Dora This is the conclusion from the 2025 report. The success of AI adoption is not a matter of tools, but a matter of organizational systems. He said, organizational systems. It refers to the foundational capabilities that support development organizations. They also state that AI's role is that of an amplifier. If the organizational system is in place, AI amplifies strengths, and conversely, if things are not well organized, dysfunction will be amplified. When I read this report, it was like checking our answers for what we had done. Finally, looking back at this initiative, ultimately, I believe these 2 points were crucial. They are. It's about a sense of urgency and leading by example. The first is, regarding my sense of urgency, I am a unit lead, and, to be honest, and I'm a bit embarrassed to admit it, until about last December, we weren't using AI agents at all. Even with the AI utilization maturity model we just discussed, I believe we were somewhere between level 2 and 3. On the other hand, there's Fukunaga-san, who was known as the Minister of Generative AI at the time, uses AI agents extensively. Around the end of 2025, Mr. Fukunaga will be in a casual Slack channel. We shared a YouTube video about starting with an AI agent. It was about an hour and a half long, so I honestly thought it's a hassle to watch. I had some time at the end of the year, so I thought I'd take a look. I watched that YouTube video and actually tried out an AI agent myself. I was truly shocked. I felt that a paradigm shift was already beginning before our eyes. AI, which is rewriting everything at an incredible speed. If we don't become the ones who fully utilize it, in the future, neither organizations nor individuals will be able to. At that time, a strong sense of crisis emerged, feeling that we would not survive. However, an organization cannot be motivated by a sense of crisis alone. The people who operate the mechanisms and devices take the initiative and lead the way. I believe it's important to lead by example through our actions. If AI can bring about 10x speed or disruption and creation. If the person saying such things wasn't using AI at all, I don't think it would be convincing at all. Therefore, the initiator thoroughly touches, uses, and becomes knowledgeable about it. By doing so, the specificity of the strategy increases. I believe it makes the story more convincing. I believe it will be the greatest driving force. Finally, here's a summary of today's presentation. Against the 2 walls that hinder organizational AI utilization, We have been addressing this issue with both mechanisms and strategies. We absorb visual barriers with the QA app platform and persistently address human psychological barriers through continuous improvement loops. That's all. This concludes our presentation. Thank you very much. Hello, everyone. Thank you for attending this session today. I am AJ from the Line Yahoo ID and Access team. Today's session will introduce IDJAG, the next generation authorization standard for the AI era, as shown on the slide. Thank you. Since the title is a bit long, we've also prepared a simpler subtitle. Who authorized the AI agent to translated into Japanese? Authorization in the age of AI. That is, the user error, the authority that humans possess. How the AI agent can safely act on behalf of the user. Gil, I will talk about this concept. This is today's agenda. First, in Agenda 1, before we delve into the IDJAG technology, first, I will explain what AI security is in the first place, and the current situation in the AI era, and after introducing the challenges we face, will then explain. I will explain IDJAG, which is attracting attention as a solution to this challenge. Next, I will explain how IDJAG actually works and show you the actual process with a demo. And on the introduction of IDJAG, the benefits for developers utilizing AI, and let me summarize the benefits for organizations that provide AI internally. To conclude, I would like to summarize today's presentation. First, before discussing AI security, please allow me to briefly introduce myself. Shimaoka and I are currently working on our in-house identity and access platform. I am in charge of the operation and development of Athens, while performing in-house operations. In the current AI era, global IT companies and global leaders in the field, we are focusing on and researching how to address AI security issues. AI is a recent trend. I believe many of you already have a concrete image in mind. On the other hand, what AI security is might be a bit vague. When I think about AI security, there's a metaphor that often comes to mind. That is a trip. I don't think we go on trips solely for safety. To have new experiences in unfamiliar lands. You will experience a joy that you don't usually get in your daily life. What we often refer to. This is to experience the work. However, if we approach this solely from a security perspective, you might find yourself in a dilemma. Everyone fearing the risks. If we prioritize safety alone, in the end, throughout the trip, I'll be confined to my hotel room. A hotel room may be managed and secure. You probably wouldn't call it travel if you don't step outside at all. The introduction of AI is similar to this. As we introduce AI into our company, the purpose of developing a new agent is to, it shouldn't just be about building an airtight security system. In this turbulent AI era, to survive the competition through AI, ahead of any other company, this breaks away from existing methods. Ultimately, a service that anyone would want to recommend. This is to provide wow. Just concerned about security. If we were to close the door on AI adoption, you will lose your competitiveness in the AI era. AI security is not a barrier to new changes. Should function as a foundation for safely moving forward. Today, I will discuss how we are building that foundation. So as the script for that, what kind of changes are happening now? Shimaoka-san will now explain this. Thank you, AJ, for the introduction. I am Shimaoka. From here, I will explain the current state and challenges of security in the age of AI. Until very recently, our use of AI was relatively simple. For example, it's a usage method where you give simple instructions like summarize this document or organize the text minutes of this meeting and receive a response. At this time, the AI it remained in the role of an excellent advisor. In other words, it generates and responds with text, images, and so on in response to prompts. Ultimately, who accesses external systems, presses buttons, and actually executes tasks. It was still human. For example, when the AI at that time was, what happens if we make a more complex request, such as summarizing this meeting, saving it to cloud storage, and emailing it only to participants? At the time, AI could summarize, but it couldn't. Existing cloud storage and against the email system, we did not have all four of these methods. Ultimately, copy the summary and save it to cloud storage. It was a human who composed the email and pressed the send button. However, the situation has been changing rapidly recently. With the advancement of technologies such as MCP, A2A, and agent-to-agent, various internal tools and systems can now be integrated with AI. Now, if we enter the same prompt, AI will perform the summarization itself, stored in cloud storage via MCP. You can also send emails via MCP. In other words, current AI is no longer merely an advisor that provides answers. It is an entity that performs operations that humans used to do. In other words, it can be said that the era of working as an agent has arrived. This allows us not only to ask questions to AI, but also by instructing the Claude code as well. We were able to achieve a dramatic improvement in productivity. However, from the perspective of protecting an organization's systems and data, we need to ask one crucial question here. What about it? The question is whether we can fully trust this AI agent. Of course, this is not to say that we should stop introducing AI. To achieve innovative speed, we will likely entrust more tasks to AI agents in the future. However, there are some facts we need to keep in mind. Unlike humans, the point is that AI agents cannot be entities that bear responsibility themselves. An AI agent, as the name suggests, an agent that temporarily borrows user permissions to act. The responsibility for the actions taken by the agent ultimately lies with the one who authorized it. The user themselves or the organization you belong to will be in alignment. Let's look at a simple example. Let's say you instructed an AI agent to share the meeting minutes only with participants. The summary itself might have been good. However, the agent misjudged the scope of sharing. What would happen if you were to send meeting minutes containing important management decisions to a public channel visible to all employees under your name? You, who instructed that AI agent to perform operations, cannot escape responsibility for the results. Even if the requesting user themselves has write permissions to a public channel, as in this example. There are often cases where you want to control the behavior of an AI agent that has been delegated authorization. However, at the same time, what should we do if we want to avoid developers who want to promote the use of AI being held back or slowed down by the time it takes to manage these detailed permissions? Is there a way to solve these two problems simultaneously? Of course there is. That solution is the theme of today's talk, IDJAG. IDJAG is a new authorization standard currently being developed primarily by companies such as Okta, which is famous for its IDP products. This specification It was first published in 2024, and then in June 2025, it was announced as the next generation authorization standard that we officially support. It is currently being developed within the IETF Auth Working Group, and active development continues, with the specification updated just last month. Furthermore, even in the official documentation for MCP, IDJAG is introduced as a method for centrally managing access control to MCP servers in an enterprise environment. By the way, this document just became stable from draft around last week, which shows the momentum of IDJAG. What IDJAG actually achieves, in terms of its specifications, is this. In the draft specification document, I've been explaining the role of IDJAG in this way, but to summarize this content briefly, the core of IDJAG is the goal is to extend the trust of SSO to APIs. In other words, IDJAG has been established through SSO, which has been established so far. The trust in user authentication by IDP, it also applies to API access between applications or between AI agent services. This aims to centrally manage, on the IDP side, which applications can access which other APIs and to what extent. Technically, RFC 8693, Token Exchange, it combines two existing RFC specifications, RSFC and Authorization Grant. So how do these two specifications combine and operate? AJ, could you please explain the mechanism? Thank you, Shimaka-san. Let's take a look at how this IDJAG actually works, its mechanism. I believe you are already familiar with the role of the IDP. It is an authentication foundation that is essential for modern enterprises, centrally managing user accounts and credentials. Internal applications and external SaaS approved by the company, or when logging into the AI service provided internally, I don't think there's a need to create new IDs or passwords for each service. Instead, internal users who, even when logging into an in-house AI service, by switching to a trusted IDP, you will be able to log in directly. When you have successfully logged in, internally, an authentication token called an ID token is issued by the IDP. The ED token, everyone's names or such as email addresses. It is a token that proves who you are. When asking an AI something, you can send this IDB token. Here, if you ask AI not just a general question, but let's say you've made a request that requires connecting to cloud storage or an email service. In this case, the AI acts on your behalf because they will be operating as agents. The IDJAG flow will be initiated. The IDJAG flow basically, all internal services, an authorization server such as Auth0 issues, even if an access token needs to be verified and confirmed. There is no need to pre-issue an access token and pass it to the AI agent. In AI generative agent models, I just received it by sending the ID token to the IDP as a proxy for the person whose ID token was sent by the AI agent. An authorization server that proves certain operations are permitted. You can reserve IDJAG. Of course, even if there is a request from an IDP, it is not issued unconditionally. IDP, this AI agent, as a proxy for this person. What code to take? after checking the predefined internal security policies. It issues an ID JAG with defined permissions. Do you remember the problem in the previous example where the AI agent mistakenly shared information in a public channel? What if we define that operation in public channels is prohibited, even when operating on behalf of a human with authority? ID JAGs are issued without the fabric chain authority. The AI agent issued the ID JAG via the IDP and send it to the authorization server and receive an access token for external resources. Naturally, this also applies to the permissions of the access token. You cannot grant more permissions than what is described in ID JAG. In other words, it will not have authorization to public channels. Received the access token, and AI agents are ultimately, by passing this access token, it can perform tasks on behalf of humans under restricted permissions. And if by any chance the AI makes a wrong judgment, even if you try to share it again on a public channel, first of all, the access token that has been secured has no authority. Access will be denied. This concludes the overall flow that ID JAG realizes. Now, I will show you a demo of how the flow I just explained actually works. The demo I'm about to show you is publicly available on the GitHub ASINs community. It is based on Aliyah the hard way. The environment configuration for this demo is as follows. The IDP responsible for login is Keycloak, an API server that mimics documents within the company. And an MCP server is set up to connect to that API. Now for the demo. Let's begin. This app is an AI agent that can be used in a web browser. These are applications already familiar to you, such as Google's Gemini and OpenAI's ChatGPT. First, I will try to log in. I will attempt to log into my account using Keycloak, the IDP that this AI agent trusts. My account. I have successfully logged in with ID JAG. So let's actually send a request. With ID JAG, instead of users making authorization decisions, the system controls them based on internal policies. Therefore, a confirmation screen asking, "Do you agree?" is not displayed. Let's take a look. We will try to retrieve documents from the API server using natural language. As you can see, I was able to retrieve 4 documents saved by default without being prompted for consent. Now, let's try deleting the document. Let me delete the top document. The deletion failed, but this leaf is what I used to log in earlier. It's not because this account doesn't have permission. The deletion failed because it is controlled by the company's policy that AI cannot be used for deletion. Now, let's switch to the admin management screen to check where this policy is managed. For this demo, we have prepared a simple UI for Adobe. When you successfully log in using an Adobe account. As you can see, the user and ID JAG have direct permission to delete documents. What about deletion operations using AI? As indicated by the red line, it is blocked. Here, the organization changes existing internal security policies. What happens if we permit deletion using AI? as an administrator. Let's try changing the deletion permission to allow. As you can see, the status has changed to green, meaning permitted. Let's return to the AI screen. Let's try requesting a deletion, similar to what we did earlier. This time, it was successfully deleted. Asking the user, "Do you agree?" each time, instead of storing those results on the app side, based on scenario policies. The benefit of IDJag is that it can automatically and securely control authorization. How was it? Actually, there are other mates of IDJag. Mr. Shimoka will provide a more detailed explanation. Thank you, AJ. First, let's talk about the more detailed benefits of IDJag. We will look at this from the perspective of users who actually use AI. Recently, I've been using AI agents, or battling with permission confirmation pop-ups asking, "Are you sure you want to perform this operation every time?" An option such as DLERC skip permission in Claude Code. And have you ever felt uneasy inside while using things like Yora mode? Firstly, asking users to consider and approve such fine-grained permissions themselves is poor UX and wastes users' time. If there is no authorization, the system should automatically reject it. And if there is authorization, it should be executed without asking the user. The developer's original role is to produce value, not to confirm and approve AI permissions. These security decisions are not something individual developers should be concerned about. IDJag frees our internal AI talent from such non-essential worries, creating an environment where they can concentrate on producing their true value. So, are the benefits of IDJag only for the user side? Of course not. From the perspective of companies and organizations, there are also significant benefits. The first is the low implementation cost. For companies above a certain size, I believe that many of you already have your own IDP and authorization server. To implement IDJag, there is no need to build new components from scratch. For example, in companies like Line Yahoo, where IDPs such as Okta or Dex are already established as IDPs, the IDJag mechanism can be implemented at a low cost without additional components. If there is an environment where Athens, an in-house authentication and authorization platform, serves as the authorization server, then, furthermore, Athens has already implemented the main functions of IDJag, so it can be used without additional implementation. Furthermore, even if the ADP does not have the IDJag issuance function, by establishing a trust relationship between the authorization server and the IDP, it will be possible to introduce the IDJag ecosystem into organizations. This means there's no need to build a new authentication and authorization infrastructure from scratch. What is the next merit? The advantage is that enterprise-wide security policies can be centrally managed. For example, even if a specific employee, such as a system administrator, has strong permissions, in an IDJag environment, the organization's security policy is applied. AI agents will not be able to directly use user permissions. The existing model, which relies on individual user consent for access to external resources, is due to the priority of operational efficiency. As a result, there is a structural problem where everything is easily authorized by default. IDJag is, this judgment is separated from the individual. We will shift to centralized management that facilitates company-wide governance. applying a uniform security policy to all employees, numbering in the thousands or tens of thousands. This will lead to improved security for the organization. And finally, lending and visibility. In an environment without IDJAG, AI agents directly use user permissions. The audit logs related to authorization should which user. It is common for only rough records to remain, such as which system was accessed. On the other hand, in an IDJAG environment, more detailed information can be utilized. This is the access token data actually issued by the IDJAG flow from the information contained in this. Which employee instructed the AI agent? And within what policy scope can the AI agent? Through which company-approved MCP or agent? Ultimately, which system was accessed? This is because it can acquire such information. It will be possible to record more transparent logs. This information can be used in various ways, including organizational security audits. That concludes my explanation of the benefits of introducing IDJAG. Finally, I would like to ask AJ to summarize this session. Yes, 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 yes. Finally, I will summarize this session. Today, within this limited time, the background of IDJAG and mechanism of operation, and the benefits of implementation. We confirmed this through a demo. I would like to reproduce the IDJAG test in my own environment. I believe some of you may be thinking that. For those in that direction, the Athens community we have released a hands-on guide called Arizaga Hardware, Claude Code, Keycloak, Athens, and combining it with an MCP server. We would like you to verify the entire flow of IDJAG. If you're interested, please take a look. Now, I'd like to return to the travel analogy I mentioned at the beginning. The hotel room might be managed and secure. I believe that if we just stay there, the real journey will not begin. The same is true for the major change brought about by AI. It's still unfamiliar, just because there are unknown risks. Your organization forever. You can't keep it locked in a safe room. However, we are not moving towards AI utilization without any preparation. We are going out with AI security. In other words, it's not about blindly trusting AI. Under whose responsibility? What authority? To what extent authorization has been delegated to the AI agent? To create a system where we can clearly understand what is happening. And the most powerful way to achieve that is, I believe it is IDJAG, which I introduced today. However, regardless of the technology or method chosen, Line Yahoo will continue to be with AI. We are embarking on a new journey. Before you all utilize AI to create new innovations, such an AI agent, I hope you will ask the question, who authorized this AI agent? Our organization? This question will be answered more clearly, more securely, and to impress more users, something that makes you want to introduce it to someone. Wow, this should bring us one step closer. With that, I will conclude my presentation. Thank you for listening for so long. Hello. Today, let's start with a question. Can AI coding tools truly increase productivity tenfold? You might have many thoughts. Of course it does. Our team was exactly somewhere in between. What we will present today is not an answer, but a record. I'd like to show you the journey that a backend server development team has experienced over the past 10 months. Let's see where the story began. We were not the ones who started it. It was a company-wide direction from LY Corporation. In 2026, LY Corporation defined its mission as wow our users, and simultaneously introduced 3 core values. One of them was 10 times faster. It was a value emphasized directly by our CEO, Idezawa, and our CPO, Shin. In February, posters saying 10 times faster were put up all over the Kyoho office. Every time I came to work, I would pass by this poster. Honestly, when I first saw the poster, I had many concerns. We also thought we were working quickly using AI. 10 times, is that even possible? My initial thought was, this seems difficult. Perhaps there are others who feel similarly. Therefore, we decided not to complain or speculate, but to measure it ourselves. We measured how much our team changed over the past 10 months. As a result, per-person hourly productivity increased by 9.24 times. It was much closer to 10x speed than I expected. The moment I saw this number, I thought, I must share this. That is the starting point of today's presentation. There were many other great sessions prepared on how to use AI. We will share the results of how our team has evolved in response to advancements in AI methodologies. Then, let me briefly introduce who we are, the ones who will be telling you this story. All presenters are Line Plus, Line Home backend server developers. Our team is building Content Spectrum, an in-house platform. AI-powered content search for Line Home. It provides classification analysis. We will proceed in 3 main acts over 30 minutes. In the first act, we will discuss what we measured to arrive at the number 9. In Act 2, I will explain how we established the 3 conditions that led to these results. In Act 3, we introduce a 4-week plan that you can immediately follow. I have included supplementary materials in the final appendix, which you can refer to after the presentation. Then, we will begin Act 1. The topic is what we measured. First, I will explain 5 terms that appear repeatedly. The first is story point. It is a value that the team has agreed upon as a score for the size of the work. The key is that it's not about time, but the relative size of the work compared to the team's capabilities. Initially, we tried to measure productivity improvement using story point, but there was a problem. As our team's capabilities continue to grow with AI, the amount of work we handle for the same 3-hour story point task has completely changed compared to a year ago. So what we created is the second term, WWP. It is a unit we directly define by multiplying the amount of code that influences the story point structure, the complexity of the specification, and the burden of verification. It was created to compare the 5 stages of work, which I will explain in the next chapter, using the same criteria. Third, development done is the time from when a JIRA ticket development begins until it is merged. We narrowed down the scope to measure this independently of QA or deployment schedules. The fourth, context engineering, is the technology that determines what information to provide to the AI. Finally, harness engineering is a technology that binds AI, like a bit and bridle, to control its direction. The explanation of harness engineering has been covered extensively in other sessions today, so if you missed it, please refer to the video later. These two terms are directly connected to the two breakthroughs I am about to discuss. This is the scope we measured. Leverage tickets completed over 10 months. I directly tallied the merged PRs for the ticket commits. Face line. Prompt context, agentic harness. We divided the work process into 5 stages based on different periods. We applied methodologies that received a lot of attention during that period. I have summarized the stages of how we changed the way we work on one slide. What I really hope you remember from this is, each stage is cumulative. Each stage builds upon the capabilities of the previous stage, adding new capabilities one by one. The baseline was when we coded directly without AI. We added the ability to fix code by asking the AI one by one in a conversational manner during the prompt stage. In the context engineering phase, we used various documents, including claw.md. We were able to delegate the project understanding itself to AI. This is our first breakthrough. We added autonomous delegation and concurrent processing to the agentic stage. However, as autonomy increased, so did the burden of verification. In the final harness engineering stage, we added a verification and management infrastructure on top. This is the second breakthrough point. Before I tell you the results, there is no separate standard for measuring AI development productivity. We created and measured a unit called WP, which I mentioned earlier. A detailed explanation of this unit is included in the appendix, so please refer to it later. Over the past 10 months, we have introduced AI tools and transformed our way of working. The per person, per hour productivity increased by 9.24 times, which is more than 9 times. This number is easier to understand if we break it down into 3 parts. First, the time it takes to process one chunk of the same weight has been reduced by 2.79 times, and the amount of work one person processed in a month increased by 3.31 times. Multiplying these two means that the amount of work produced by the same person in the same amount of time increases 9.24 times. This time, we've laid out the monthly trends across 4 metrics. Starting from the top left, clockwise, the sum of WWP of commits per month. This is the throughput per person based on the number of completed story points. The background color of the chart shows 5 stages divided by period. The key is that all my metrics show an upward trend in the same direction. However, every time we changed our way of working, it wasn't always for the better. In the context engineering stage, the information that could be conveyed to the AI was limited, so progress stagnated for a while. In the agentic phase, we ended up handling too many tasks simultaneously. As a result, the throughput dropped because it exceeded the scope that humans could review. And my metrics simultaneously peak in April. This is the effect of the harness engineering breakthrough. Looking at the numbers alone, 9.24 times seems to be the most striking. However, there was another change that we felt was truly valuable. The size of the problem that the team can handle and the way we define work has changed. Before its introduction, the back-end server focused on simple tasks, while the front end was not properly developed and only partial testing was conducted. The completion criteria were also very ambiguous, to the point where the median was the limit. But now, even though we are a back-end team without a front-end developer, All developers on the team are now able to handle UI front-end and back-end for large domains. Additionally, all code and documents generated by AI were automatically verified. The median number of conditions completed in one attempt also increased from 1 to 3. What we do has become clear. It's not just about getting faster. So we refined the definition itself. So, how did we achieve this change? Now, Lin Hyo will continue the presentation. Hello, I'm Lin Hyo. In Act 1, what Shin measured, and you've summarized what 9.24 times means, haven't you? So now let's move on to the most important question. How exactly were the results created? In Act 2, I will explain the 3 conditions that enabled a 9x efficiency improvement one by one. I have gathered the 3 conditions I just promised on one slide. The first is context engineering. With Claude.md and module documentation history, this is an environment that explains our team and project to the AI. This is the first breakthrough, which we achieved in November of last year. Second is harness engineering. Second, verification, skill document. This is an infrastructure that safely supports autonomous delegation with these 4 pillars. This became the second breakthrough point in March of this year. Third, we refined the work definition, which is work definition refinement. This clarifies the requirements and completion criteria. The number of completion conditions increased from 1 to 3 based on the median, allowing us to assign larger domains. This happened almost simultaneously with the second breakthrough. It can be seen as a natural progression. Then, I will sequentially show you how these 3 conditions were created. These are the stages we have been through. Baseline prompt. Context agentic. Harness engineering, like this, there are 5 of them. However, the real change occurred not in these 5 stages, but in 2 breakthroughs between these stages. The first breakthrough was in November of last year. When moving from a prompt to context engineering, we created and refined Claude.md. After providing the AI with the project's rationale and work history in a single document, even with the same prompt, the efficiency jumped by several times. It was the moment when it transformed from a simple auto-completion tool into a colleague we could entrust tasks to. What we did for the first breakthrough was surprisingly simple. To AI, create a 1-page document explaining our team, and we prepared a command that automatically records work history. What you see on the screen is part of Claude.md, which was introduced in November of last year. The project overview includes things like the 7-module structure, code conventions, and commit format for content spectrum. We made the AI automatically read and start this for each session. And with skills, we also automated the recording of the AI's work history. For example, if you type the dev start command, starting with the tickets and branches, they were made to write a development plan document. I had them write a planning document, and by doing this, the AI now understands the goal and progress of each ticket for every task. As a result, the history of planning and developing each task, along with the code, was documented. So AI. As it reads automatically, the code being generated has changed. Ticket throughput also increased. And ticket throughput, the task processing time, was also slightly reduced. The amount of work processed in a month also slightly increased. However, what's interesting is, the code output itself actually decreased for a short period, from 34,000 lines to 20,000 lines. It has dropped by about 39%. However, the tickets processed during the same period, it increased from 25 to 32. What this means is that unnecessary code has been removed, and the proportion of proper code has increased. This is the first breakthrough point. It's not AI tools that brought about change, but rather context engineering. The reason for the additional verification in harness engineering is explained by this 60-file incident. It was March of this year, and we were actively increasing the number of self-reams in the AI GAC phase. While doing a PR review, the agent asked me to review 60 files in a legacy area that should not be touched. Humans found that it had been arbitrarily modified. Fortunately, as it was before the merge, there was no operational impact whatsoever. The cost for recovery was about 1 day in total. Although the cost was small, we learned a great deal. We could not control the autonomous agents using only descriptive documents such as Corda Envy. As an agent's autonomy increases, the burden of verification explodes proportionally. The limitation is that people only review at the final stage. So we reached the conclusion that verification should be moved to the infrastructure. If this had gone through to deployment without being caught in review, it was an incident that could have taken days or even weeks to recover from. The key is that we cannot leave such potential risk to chance every time. As harness engineering was applied, we reached a second breakthrough. After applying harness engineering, the autonomy of AI has increased, but rather, it became safer. The commonality between these two breakthroughs is clear. It's not that we changed AI tools. We changed the way we work. What was our team's conclusion after this incident? It's not about using less AI. It was about creating a structure to measure and verify the results produced by AI. We achieved. We organized the few story points we had into a framework. First, identification, planning, development, verification, delivery, review, release. We divided the flow into 7 stages. We automatically track progress by recording it in YAML. In fact, it is the core of our harness engineering. Second, we created several agents with different personas for each job type, such as code review agents and UI verification agents, for each stage of the process. We mutually review the specifications and development progress. Third, repetitive tasks were standardized with skills or commands. Fourth, it automatically blocks dangerous commands via hooks at each execution stage and verifies plans and results. We did not initially introduce all areas of harness engineering from scratch. We started with variables that were immediately helpful for operations, and we are still using them while continuously refining them. This is the data that resulted from the full-scale introduction of harness engineering. From April this year, as the 4 pillars started to function properly, all metrics compared to agentic, it more than doubled. A verification infrastructure. This is the effect that came about as we started to support autonomous delegation. Among the effects of harness engineering, the most significant was the reduction in processing time for large tasks. A major task moving from agentic to harness engineering. A task that was 8 story points is now 3 times faster. Then why is the effect greater for larger tasks? This is because the burden of verification due to complex qualification tasks is greater. The committee had agreed on the specifications beforehand. Multiple agents automate verification, and this is the result of standardizing skills and having the post-stabilization role verify large tasks, which reduce the burden of verification. Now, Janook will take over and present a 4-week plan that other teams can also follow. Hello? In the last part of our presentation, we will show you the 4-week plan from week 1 to week 4. To which teams can it be applied? After organizing the conditions, I will now conclude with a single message. The fastest way for an organization to change is for one person to experience it directly. One person, starting next week, you can become. We know it's good, but how do we start within our team? As you've been listening, this thought must have crossed your mind. I would like to share the quickest way to experience productivity improvement. From now on, I will show you the 4-week plan. It's about directly applying it to your own work. Please don't wait to persuade an entire organization or for large-scale adoption. That can be done right now. It would be good to start with the smallest part. The first week is a stage where not a single line of code is touched. To AI, our team, and explaining the project. We're trying to create a Claude.md initially from 10 lines. 15 lines should be enough. Based on that, to AI, what is the purpose of this project? Where is this method called from? And similar read-only questions, module structure, and we also try to organize the coding conventions together, but we do not change a single line of code. The safest starting point and time is 2 to 3 hours are sufficient. In weeks 2 and 3, we applied AI to the area of modifying documents and metadata. Automatically writing documents or readmes, creating a commit message, whether we use Jira commits or not, or changing the ticket status. It's about automatically generating PR content. All of these parts are safe areas that do not affect the operating code. In the process, we began extracting 1 or 2 repetitive tasks as skill commands. This is the stage where the team's skills are established. It would take about 10 to 20 hours. The risk is still low. In the 4th week, we expanded into the code area for the first time. However, it's not about autonomous delegation, but rather reviewing and approve in a workflow format. A safety net will be in place. You shouldn't just say, do it yourself, person. After organizing the requirements, the AI creates a plan. Someone approves once. Also, if AI develops, a person approves it again. Then, it goes through a code review and is merged. Because a human had to pass through the gate twice, a small PR, it's a good idea to start with 1 or 2 cases. It takes about 20 to 40 hours. The risk level will increase to a moderate degree, but such gates provide stability. I'll briefly explain ROI, but please refer to the appendix for more details. A team of 5 people, based on 6 months. We are assuming that the entire team invests about 1.5 weeks per person in the first month. Then, for the remaining 5 months. Even if we only achieve double the efficiency, the organization grows to be able to do the work of 1 or 2 more people. Our team actually invested up to 9.24 times, but we conservatively reflected only 2 times in this calculation. What are the criteria for continuing or stopping work when applying harness engineering or workflows? You can adjust it to fit your team's characteristics. To which team is this applicable? That's the most frequent question we receive. I have organized it based on 5 criteria. What are the recommended conditions? From 2 to 10 people. The project has multiple modules with clear boundaries to avoid. There is a ticket workflow like Jira. There are no issues with utilizing Frontier LLM. It's good if it's a team where a PR review culture is well established. Our team, under these conditions, we apply AI tools sequentially, and then we were able to achieve results by changing our work methods. Conversely, I will frankly discuss cases where application is difficult. A one-person team or a large organization with over 50 people, monolithic projects with unclear boundaries, PR, or in cases where there is no ticket workflow at all. Or an environment where it's difficult to use frontier models because there's no enterprise contract and the culture of pushing directly without review. If this is the case, rather than immediately reviewing the adoption of AI, we focused on changing the team's constitution. I think it would be better to improve that first. Unconditionally, our team's 9.24 times. This does not mean that you can simply take it as is. The more conditions are met, similar, this means that we can expect an effect. Would you please summarize this for us one last time, Hongju? This is Hong Jung again. I will summarize today's presentation in one sentence. A tenfold increase in AI productivity is not the result of merely adopting AI tools, but rather a re-engineering of our working methods. Tools such as Claude Code, Copilot, and Codex were all equally available in the market. The reason for the divergent results, even with the same tools, is there was an environment created by our team around the tools. We will create an environment called Context using Claude.md. Through harness engineering, the team directly created and applied a validation environment. We were able to increase productivity. If you don't change the environment, the tools won't change. Our entire team understands AI and embraces it like a colleague. We deliberated together. At that moment, AI is not a tool that receives commands, but we have become colleagues who make decisions together. The result: productivity by 9.24 times, 0 outages for 10 months. Hot fixes return to less than once a month. There was something Mr. Itazawa emphasized. AI? Cool, but a team member. We need to redesign our entire work process by incorporating AI from the beginning. I believe that only when these words become a reality can we achieve a 10x speed improvement. It's about embracing AI as a team member and redesigning our workflow from the ground up. If that's not presupposed, a 10x speedup remains just a claim. Our team's case is about when a team's words actually became a reality. It was a record showing what had happened. Are you just using AI as a tool, or just giving commands without context, if you don't have an environment to verify? Now is the time to re-examine it. Try working with AI not as a tool, but as a team member. You can start right now not in the distant future. Thank you. Hello, everyone. I am Nagasaki from the Search Ad Development Unit at Line Yahoo Corporation. Today, we aim to eliminate the need to look at logs. This is achieved through automated log collection and AI-powered log understanding and decision-making support. I will speak on the topic Slack-centric alert operations. Today, it started with a keynote, and you've listened to about 6 minutes of the 30-minute session. From here, I hope you will enjoy 2 15-minute short sessions. As the title suggests, I will be speaking about how we, on a daily basis, the exhaustion from system alerts that we had been struggling with, we dramatically improved it using CCAI. I will explain the reasons for that. I'm sure some of you listening now, I believe there are some of you who are tired of the alerts that sound during the night and on holidays, and of checking long error logs. Today, I would like to introduce an example of operational automation using AI that all of you can immediately emulate in your own teams starting tomorrow. Again, I am Toshiki and Nagasaki from the Search Ad Development Unit. Currently, we are focusing on search-linked shopping ads, specifically search engine design. We are developing and operating. I have been in charge of the backend for about 6 years, around the search engines of EC and gourmet services, even on the train. Today, I will talk about what I have struggled with in system operations. I will be discussing how we improved operations by automating log collection and leveraging AI. First, I will explain why we decided to pursue such automation and AI utilization. It all started with a very from the field of practice. My team develops and operates the delivery system for search-linked shopping ads, as I just mentioned. The team we operate. A massive amount of logs flow through our systems every day. Since system uptime is directly linked to sales, it is important to detect status changes quickly. It is a crucial mission to keep it running for as long as possible. To ensure that critical system alerts are not overlooked, our team has been working on alert maintenance since the early stages of the service launch. This is an initiative where all team members check and share alert notifications that occurred from the previous night until the morning of the day. Through this alert maintenance, all members share knowledge of the system status and the alerts that occurred. Among these, if issues requiring additional investigation or action were found, we would assign a person responsible and a deadline, and then work to resolve the alerts. However, as the service grew, the number of notifications became enormous. The time for this alert meeting became longer and longer. There were days when we spent about 60 minutes a day on these alert details when they were long. As a result, team members were exhausted, and it was tough to keep monitoring alerts in this state during the New Year holidays. It was a very stressful situation. This is a log of the game with Sunday. By combining the log infrastructure API and AI, we dramatically improved the situation. That is the highlight of today's talk. For example, what kind of things happened? More and more decision-making for readiness and response is being completed on Slack. Additionally, thanks to the AI remembering past cases, even if we forget them, we can instantly recall them. In addition, even system messages that might seem difficult for new members at first glance are now quickly understood, thanks to AI summarizing and analyzing the logs, allowing them to catch up on occurring events. As a result, the alert meeting that I mentioned earlier, which used to take about 60 minutes, has now been shortened to approximately 10 minutes. Today, in this flow, we will explain how we have proceeded with improvements. Next, I will discuss how our alert operations have changed. First, in order to improve, I would like to reorganize what our alert response flow was like. This is how it generally flowed. First, we receive a Slack notification, and then humans manually open the log database. Then, from the vast amount of logs in the log database, we will we again manually find the relevant logs. Once the relevant logs are found, we analyze the extensive content and post the necessary information for response preparation and decision-making, as well as the response decision on Slack. If additional investigation or action was deemed necessary, A ticket would be created and assigned to the relevant person. That was the flow. Among these, what had a particularly high cognitive load and became a bottleneck it was two things: finding the relevant logs and interpreting them. To be more specific, the problem we faced with log searching was that the content notified on Slack is, after all, it was limited to simple information such as metrics, specifically the number of alerts generated, or fixed alert names. That's what it was. The specific messages were not known until we looked at the log database or accessed the server. Therefore, every time an alert sounds, a person has to take action. It was difficult to anticipate how to respond in such a state. Of course, our team tried to streamline our work, for example, by creating a shortcut link to search for error logs from the past 15 minutes. However, because the filtering condition is time-based, if confirmation was delayed, it would have been necessary to change the narrowing conditions. Furthermore, cross-referencing the alert titles with the corresponding logs manually was a very laborious task. Above all, investigating logs from a smartphone after working hours, especially when out and about, was quite a high hurdle task. Another challenge is that it's tough to make sense of the vast system messages. Regarding this, a certain level of technical skill is required to decipher what is happening, where, and for what reason from stack traces that span tens of lines. In urgent situations, even skilled engineers find it difficult to make instant decisions. That can happen. In this way, in actual operational scenarios, not only general programming knowledge, but also knowledge specific to the product is required. For example, let's say the system timed out. Let's say such an error message appeared. Generally, I believe the urgency of the response is determined based on the log level, such as 1 or error. However, in actual practice, they inevitably occur due to releases and maintenance. In such cases, you can ignore it, I think it's not uncommon to have operations with implicit exceptions. By the time it reached this point, it was a state that could only be called a spell for new members. We considered 2 points then. The first one is, instead of humans going to look at logs, the logs come to us. The other one was, if reading logs is painful, why not have AI translate them? Specifically, this is the approach we took. First, let's have the logs come to us. Regarding this, we created a system that uses Slack notification messages as triggers to retrieve logs from a log database and automatically reply to Slack. This is obtained via an API, using an in-house PIS as a worker. Slack notifications. It starts immediately as a trigger, so even with the 15-minute filter I mentioned earlier, it can gather enough logs. Also, with the systemization, information is now collected more accurately and thoroughly than when it was manually collated. In addition, the acquired logs are passed to the LLM for analysis. AI extracts the severity of error content from lengthy logs. We instruct it to extract the frequency of occurrence, possible causes and scope of impact, and recommended actions, and then summarize them in an easy-to-understand format for humans. This has allowed us to quickly decipher truly necessary information from the logs. By automatically replying with error logs on Slack, we are now able to check the contents of the logs without having to transition from the Slack screen. This has eliminated the need to search for logs. It's as if we're glued to this alert channel. Alert occurrence immediately. It felt like we had hired a dedicated engineer who would edit the log content in the thread. And the AI's automated analysis results are also posted along with it. We can review the content with the ALR logs, severity, frequency, possible causes and impacts, and recommended actions, all organized as I just mentioned. Humans no longer need to painstakingly interpret complex system messages. This has significantly increased the speed of our situation assessment. By improving these two bottlenecks, the alert handling that I mentioned at the beginning, which used to take 30 to a maximum of 60 minutes, has been shortened to just 5 to 10 minutes. Above all, through the efforts mentioned, the psychological hurdle of checking alert content has been significantly reduced. Actually, we are proud to say that the biggest achievement of this initiative is that it has enabled us, as humans, to make decisions with confidence based on the evidence presented by this AI, rather than simply saving time. So far, I've spoken as if everything went smoothly just by introducing AI, but when we actually started using it, there were some rather messy parts. It wasn't a one-and-done solution, it was merely the beginning of trial and error. Also, because we couldn't solve everything with just pretty words, I'll talk about the tuning we undertook later. Regarding the first point, it means that AI also needed onboarding. I think you've heard many times in today's sessions that context is important for AI to answer correctly. This naturally applies to alert response as well. An AI without any knowledge can only provide generic answers. Regarding the urgency of the response, we can only make a simple judgment. If it's an error, immediate action. If it's a warning, observe and monitor. However, in a test environment, there might be cases where errors are intentionally generated for temporary operational checks. Taking into account the actual circumstances on site and responding to errors is indispensable in the context of products and actual operations. These stories are not limited to AI. They are the same for us humans. So what we thought was to incorporate metadata, such as past cases and environmental information, into the AI prompt and convey it. This has enabled the AI to make flexible decisions. What we've devised here isn't just about incorporating past response records and procedure manuals into the prompt. This means that information such as operational rules and system maintenance information is also being input. For example, this error in the QA environment this is a known issue and we are currently addressing it, so immediate action is not required. We include messages like these. Then, the AI makes judgments similar to ours, determining whether it's an unknown critical error or an error that has been recovered from. We input links to tickets scheduled for resolution and maintenance notification threads into the AI, and it includes those in its replies. We are now able to recall the context immediately and make confident decisions. Generally, if an alert doesn't require action, you might think it shouldn't be notified in the first place. However, in reality, it may not always be possible to immediately delete all unnecessary notifications. Or perhaps there are unavoidable alert messages that occur within a scope beyond our control. This is where we, as a team, have been working hard to cover the operations. Nowadays, AI can take on this role. Also, instead of leaving everything to AI, we strive to improve the user experience by incorporating rule-based approaches. For example, frequently used Slack stamps, such as observe or requires action, are automatically replied to in the thread. Now, people only need to press a stamp. In addition, by extracting important keywords contained in error messages and stamping them, we can now quickly understand the content of alerts without having to open the thread. I will now introduce an example of a case where we were actually able to detect an anomaly by introducing such an alert bot. In our system, we connect with components from other teams. However, a validation error occurred, indicating that the linked value was outside the expected range. Because our alert bot, which is close to our judgment level, told us this is an unknown error, we were able to inquire immediately and notice the error before the production release. Finally, I'd like to introduce the lessons learned from this initiative. One is to start small and expand gradually. Instead of insisting on integrating AI from the beginning, why not start by having the logs automatically reply to Slack? If you start small, you will gradually see what you want to utilize with AI. The second is to prioritize the user experience. As with the Slack stamps I mentioned earlier, without sticking to AI, humans, we believe that resolving the biggest bottleneck this time has been effective. The third point is that prompts need to be nurtured. It's not a one-and-done creation. By changing daily cases, systems, and team judgment criteria, and by conveying these to the AI, it becomes capable of making decisions that are more aligned with ours. What I talked about this time, regarding the content, we didn't build an especially large system. The important thing is to start small. We encourage all your teams to consider introducing an AI partner, if you will, to help make daily operations easier starting tomorrow. This concludes my presentation. Thank you for your attention. Hello. I will be speaking on the topic of teaching AI code etiquette. I am Aguchi from the Media CTO SBU. Nice to meet you. Introducing AI allows code to be written faster, but reviews cannot keep up, leading to a bottleneck. I believe this is a challenge that any team adopting AI will encounter. Today, I hope you'll take away how our team broke through that wall, and the idea that walls can be broken down with the right ideas. Let me briefly introduce myself. I joined what was then Yahoo in 2007. In 2014, I transferred to the current SportsNavi. After iOS development of the SportsNavi Baseball Scores app, I am currently in charge of the entire baseball system. Currently, we are in the process of incorporating AI coding agents into that development. Today, I will talk about what I actually experienced there. The presentation is divided into 5 parts: background and challenges, just a quick glance, 3 quality checks, results, and a mechanism that continues to grow. I will now discuss them in order. Chapter 1, Background and Challenges. What's the theme? Why did the review bottleneck occur? We can write code quickly, but reviews can't keep up. What does that mean? This is a well-known challenge in many teams that have introduced AI. Among you all, many of you may be experiencing this firsthand. We also encountered this challenge. First, let's look at the causes of this. The system we are dealing with is a large-scale baseball system with over 50 tables and over 70 APIs. Why we were promoting it? To rebuild the asymmetric front end. BFF. The responsibility for handling data was transferred to the BFF. The front end focuses solely on display operations. However, this was a 3-year refactoring plan. It didn't progress as smoothly as I hoped while handling daily tasks in parallel. Therefore, we decided to accelerate development. We introduced an AI coding agent. However, it did not accelerate as much as expected. What happened? By introducing AI, the speed of writing code certainly increased. However, only the coding speed increased. While we were able to write more code faster, other issues came to the forefront. That is a review bottleneck. However, it's not just a matter of reviews not keeping up with the volume of PRs. This is because instructions vary from person to person. The coding style of the generated code is inconsistent, so many issues are pointed out during each review. I fix them and then have them reviewed again. This back and forth of pointing out issues and making corrections dramatically increased. This was the true nature of the bottleneck. So, as written here, it's not just about being fast. If the team's style was not aligned, even if we accelerated with AI, the bottleneck would simply shift from coding to review. So what do we do about it? We will now move on to Chapter 2, Approach. The policy we established is implicit knowledge to style guide. In other words, it's about verbalizing the team's etiquette. In this chapter, we will discuss how we understood the cause of the congestion. I will talk about how we approached this. Let's delve a bit deeper into the causes of the bottleneck. Why are the styles not consistent? This isn't to say that any specific person is bad. Each member had their own slightly different rules for how they wrote code, and these differences gradually expanded. This is the real reason. So how do we align them? Even if you gather everyone's rules, you'll only end up with the average of the variations. To unify something, you need a central axis. The axis we chose was design philosophy, not just personal preference. With the mindset of why it should be written this way, the people who spearheaded the design had the clearest understanding of this. What we noticed there was to transcribe the tacit knowledge. This is the idea. They are shared as experiences, but not written down as rules. That design philosophy, we verbalize them as a style guide. This is the true nature of best practices. We make implicit knowledge into visible rules, read by AI. It's used for both implementation and review. This was the starting point of our efforts. So how did we extract that design philosophy? We focused on PRs. How should the designer's PRs be written? And the reviewed PRs show what problems are being pointed out. Just looking at the completed code isn't enough. The criteria for judgment are not visible. However, in PRs, and the traces of why that judgment was made remain. By analyzing PRs, not code, we were able to extract design philosophies. This is the actual prompt we used. We approached it from two angles. From the PRs submitted by the designer, the rules and the testing trends. What kind of feedback do we give on reviewed PRs? You can see where to draw the line. The point is, the reviewer and the developer. We analyze this from both the creators and the reviewers' perspectives. However, the writing style only tells half of the story. What is not allowed only appears on the review side. It was only when both sides were complete that we were able to articulate the design philosophy. This is a part of the contents of the best practices. This is a design rule for testability. It describes guidelines on how to determine whether a class should be split. For example, if the logic you want to test is hidden in a private method, it's a sign to extract it into a dedicated class. If the mock settings are too complex, it's a sign that responsibilities are mixed. What are the style guide rules? The designers, it was born from the experience accumulated during actual development. This is precisely the philosophy the designer held. This is the core of the system. Chapter 3, 3 quality checks. Instead of relying on a single point for quality checks, we embedded them at 3 points in the development workflow. Why did we do that? I will explain on the next slide. This is an overview of Chapter 3. We are code quality. We are protecting it at 3 different times during the development process: when implementing, before submitting a PR, and when reviewing. Why did we divide it into 3? This is because if there's only one check, something will always be missed. First, when implementing. By having AI read the coding standards before implementation, from the start, code conforming to our style guide is now being output. Rather than fixing things later, the most efficient way to maintain quality is to avoid creating misaligned items in the first place. The second is before submitting a PR. Before asking someone to review it, AI self-reviews the code it wrote against the style guide. Minor discrepancies are corrected at this point. Therefore, when it reaches the reviewer, the number of fantastic things has significantly decreased. The third is when reviewing. Before we proceed to a review with a human, the AI will first look over it. Because AI performs style and routine checks first, people will no longer have to spend time on that. As a result, AI and humans shared the review workload. People can now spend their time determining whether the logic and design are truly correct, rather than on the detailed way the code is written. First, as I mentioned, the hurdle of faster isn't always better. I will show you on the next page whether we were truly able to overcome this with 3 mechanisms. This is the actual data. We have arranged the PRs issued for the development of the entire baseball system on a monthly basis. The bar graph shows the number of PRs per person, in other words, productivity. The line graph shows the median lead time. In other words, it's the time until a PR is merged. There are 2 vertical lines. The vertical line on the left indicates AI adoption. The vertical line on the right indicates the introduction period of the style guide. First, please look at January and February, immediately after the introduction of AI. Productivity actually dropped. Lead time is worsening. This is the hurdle we faced, where simply introducing AI actually caused stagnation. Next, Please look at what happened after we introduced these practices. Lead time decreased. In May, it reached its shortest point. At the same time, productivity per person has also increased. Of course, other factors such as project status and the number of people involved also have an impact. However, even within that, lead time is steadily decreasing. This is where I believe the effects of good manners clearly manifested. Introducing AI alone caused stagnation. By teaching our coding etiquette, we were able to achieve both quality and speed for the first time. This is our achievement. This is the final chapter. Up to this point, I've talked about creating the system. But what's truly valuable is that it continues to grow. It's not about just creating something and then being done with it. We designed it to continue iterating. I will discuss that point. The three-stage check introduced in Chapter 3. Even so, new issues will still arise. There are also essential issues found in human reviews. Even minor oversights caught by AI are both important clues. This means that it slipped through the checks. The conventions were ambiguous. This is because it originally didn't exist. Then, the team members discuss the feedback and incorporate it into the guidelines. Then, the AI will act based on that feedback moving forward. It's not a one-and-done creation. It continues to evolve while in operation. This is how coding conventions are refined. Finally, this is what I wanted to convey to you today. Teaching AI the team's coding conventions. Through this accumulation, speed and advancement will no longer be a trade-off. The initial crossing the hurdle that simply being fast is not good enough. It's fast and it's good. You can achieve both. The key is to convert the team's tacit knowledge into a format that AI can read. I believe this concept can be applied to your teams as well. Please give it a try. Thank you for your attention today.